We are back again. Last week we could not be back. Now we are back again. So we are waiting for few people to join. We are back again. Last time last week we could not be back. So let's wait for people to join. Today we will be going through one shot of binomial theorem. So it will be completely one shot. You can invite any of your friends to this. Okay, so we are going through one shot. So wait for 1 2 minute and then we'll start. It's a time for binomial theorem to start. So we are waiting for everyone to connect. So is everything fine? We'll hardly take 1 or 2 minutes to start the lectures. So if you think, what do you mean by binomial theorem? If we try to think what is binomial theorem, so we will start with the brainstorming. Okay, we'll think that how binomial theorem started. So that will be our aim first. So what is binomial expression? What are the terminologies? So these all things we'll study. This is a very short and very marks giving topic in JEE. So we are overall ready with our setups and everything. So now let's continue. We can continue. So binomial expression. Binomial expression. So what will happen? Binomial expression is an expression. An expression containing operations of two variables. Okay. So we can say that it is an expression which contains the operation between two distinct variables. Two distinct variables. Okay, variables or identity. Okay, got it. So we are telling you some examples are, now if we will take x and y and we'll try to form some equation. So we can say that x plus y, okay, x square y plus 1 upon x y square 3 minus x. So you see they are distinct identity. Okay, they are distinct variables, they are distinct identity. Root under x square plus 1 plus 1 upon x cube plus 1 to the power 1 by 3, and we can have something etc. So you can say that they have more than more, they have two dissimilar identities. Okay, now like in binomial theorem, before binomial theorem or in binomial theorem only. Okay, so this is binomial expression. Okay, so now terminologies that will be used here. Terminologies used in binomial theorem. Okay, so we'll proceed with this terminologies used in binomial theorem. Okay, see what will happen. if we have a factorial notation, for example, if I write n factorial, what does it mean? It means n minus 1, n minus 2, dot dot dot, 3, 2, 1. So it is from 1 to n. We are multiplying a term from 1 to n. Okay? You should be knowing that n belongs to natural number. Okay? If it is n belongs to natural number. And this will become 1 when n is equal to 0. Okay? So you should be knowing this. What can happen? We can further write this as n into n minus 1 factorial. Is it correct or not? Yes. And what will happen? We will understand that if we have a term written like NCR, so we'll write this as n factorial upon r factorial into n minus r factorial. Okay, n factorial upon r factorial into n minus r factorial. So this is the way we'll perform, and here it will be n and r. They belongs to natural number, and n is bigger than equal to r, bigger than equal to 0. So this is the minimum condition. So r could be 0 also, r could be 0 also, okay? And this NCR is written as sometime n and r also, okay? We are moving ahead. More properties related to NCR will perform it in upcoming section, okay? Now, statement of binomial theorem, okay? Statement on binomial theorem. What will happen? Now, in binomial theorem, we are majorly trying to study. So, in binomial theorem, we are trying to study, trying to study expansion of binomial expression. So, for example, we want to learn y plus x to the power n. Maybe we wanted to learn x square y plus 1 upon x y square to the power n or n plus 1. So we can learn x cube plus y to the power n. We wanted to learn as x plus 1 to the power k, etc. Okay, this is what we are trying to learn from binomial theorem. Okay, So binomial theorem is something which is showing us the expansion of binomial expression. Okay, now we'll go with the expansion. So what will happen? Now we are going with expansion. Okay, expansion in the sense statement of binomial theorem. Okay, we are going through statement of binomial theorem. If we have x plus y to the power n, we express this as n c0 x to the power n minus 0 y to the power 0 plus nc1 x to the power n minus 1 into y to the power 1 plus nc2 x to the power n minus 2 into y to the power 2 plus nc3 x to the power n minus 3 into y to the power 3. It will keep on going till it is nc n minus 1 x to the power 1 y to the power n minus 1 plus ncn x to the power 0 y to the power n. So this is the way expansion will happen. Okay, if you see it, we can write it simply as summation of ncr x to the power n minus r y to the power r is from 0 to n, isn't it? Okay, okay. So my question is saying that how this expansion came out. Okay, how we got that this will come out. So there was Pascal. Okay, so there is a Pascal's triangle. Okay, so there was a scientist Pascal. Okay, there was a scientist Pascal. What he did, first he found x plus 1, x plus y to the power 0. He found that it is coming out to be 1. Okay, then he did x plus y to the power 1. The coefficient of x and y is 1 and 1. Then he went with x plus y whole square and he solved it like on pen and paper by writing on some paper. He got it's 1, 2, 1. And again when he went with x plus y to the power 3, it was 1, 3, 3, 1. And when he went with x plus y to the power 4, he got 1, 4, 6, 4, 1. And when he went with x to the power y to the power 5, he got 1, 5, 10, 10, 5, 1. And similarly, he found that this is the thing which is happening. Okay. And when we try to find these things, how these are coming, we will find that they are nothing but NC0, NC1, NC2, NC3, NCn minus 1, like this. Okay. Okay. So this is coming from Pascal's triangle. Now standard expansion. Okay. So we did expansion of x plus y to the power n. We are doing expansion for x minus y to the power n. Can we say that it is nc0 x to the power n minus y to the power 0 plus nc1 x to the power n minus 1 minus y to the power 1 plus nc2 x to the power n minus 2 minus y to the power 2. Similarly, it will keep on happening the way we did previously. It is ncn minus 1 x to the power 1 y to the power n minus 1 plus ncn x to the power 0 y to the power n. So if you see, it is simply we can write this as summation of r equal to 0 to n minus 1 to the power n ncr x to the power n minus r y to the power r. Okay, this is r. Okay, so this is it. Okay, now what will happen if we add 1 plus 2? So 1 meaning x plus y to the power n plus x minus y to the power n. What are we going to get? In this we got summation of r equal to 0 to n ncr x to the power n minus r y to the power r plus summation of r equal to 0 to n minus 1 to the power r x to the power n minus r y to the power r. You will see that the first term is having plus, second term will come with minus. So second terms are going to get cancelled and we are going to get simply nc0 x to the power n nc2 x to the power n minus 2 y to the power 2 nc4 x to the power n minus 4 y to the power 4. It will go dot dot dot. We don't know last term whether it will end up with even or odd, so that is why we are going with this series only, and we can't comment about the last term, isn't it? So now we have come to some questions. Okay, now we have come to some question. Coefficient of x to the power 52 in the expansion of m equal to 0 to 100. So everyone, it's a JMA's time, so try to solve every question along with me. That will help you very much. So in this, what will happen? The coefficient of x we can say that this expression is written in the form of 100 CR x minus 3 10 minus r q to the power r, isn't it? So can we say that it is somewhere, I'm writing it clearly, okay? It is m equal to 0, 100, cm x minus 3, 100 minus m 2 to the power m. If we write it, can we say it is 100 c0 x minus 3 to the power 100 2 to the power 0 100 c1 x minus 3 100 minus 1 which is 99 2 to the power 1 100 c2 x minus 3 to the power 98 2 to the power 2. It will keep on going and we are going to get 100 c99 x minus 3 to the power 1 2 to the power 99 plus 100 c100 x minus 3 to the power 0 2 to the power 100. So if you remember, this is simple a binomial expansion of x minus 3 plus 2 to the power 100. Can we see that it is x minus 1 to the power 100? Now we want coefficient of x to the power 52. So what will happen if we expand this term? It is what? 100 cr x to the power 100 minus r minus 1 to the power r. This will be somewhere summation like this. In this, what will happen? When we are trying to get 100 minus r equal to 52, what is the value of r? R will be 100 minus 52, which is nothing but 48. So can we say that if we expand, the 52 term will come out to be 100 c48 x to the power 4 x to the power 52 minus 1 to the power 48. Can we say the term is nothing but 100 c48? So the coefficient of expansion in this expression is 100 c48. I think you got it. Now moving ahead. Sum of coefficient of all the integral power of x in the expansion of 1 plus 2 root 2x to the power 40. So power should be integral. So what will happen? We are given expression. It is 1 plus 2 root x to the power 40. So expansion will come out to be somewhere 40 c0. Now we'll do power on this only, okay? 2 root x to the power 0. 1 will come out to be something 1 to the power something is 1 only, plus 40c1, 2 root x to the power 1, 40c2, 2 root x to the power 2. It will keep on going. We are going 40c40, 2 root x to the power 40, isn't it? Now see what will happen. This is coming root under only. This is odd power and there is square root. So this will come out to be odd power. This will come out to be radical only. Radical meaning fractional power. Okay, this will come out to be radical or fractional power. So even part is coming even integer type. This will come integral power. Okay. So how to eliminate this thing? Okay, how to eliminate this thing? So we'll consider that we are going to make 1 minus 2 root x to the power 40. And we'll find that the expansion of this is what? 40 c0 2 minus 2 root x to the power 0 plus 40 c1 minus 2 root x to the power 1, 40 c2 minus 2 root x to the power 2. It will keep on going. We'll get simply 40 c40 minus 2 root x to the power 40. So you see that when we have even power, it is going to be positive, and when we have odd power, it is going to be negative. So in order to eliminate this radical power, if we add this and this both, can it be? So we'll add 1 plus 2 root x to the power 40 plus 1 minus 2 root x to the power 40. So what will happen? This part and this part is going to be cancelled. We are left with 2 times of 40c0 into 1, 40c2 into 4x plus dot 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 40c40, 2 to the power 40, x to the power 20. So these are the coefficient. So we have to find the sum of the coefficient, isn't it? So we did double this time. So what will happen? Now we'll put x equal to what? So on putting x equal to 1, what are we getting? We are getting 1 plus 2, which is 3 to the power 40 plus 1 minus 2, minus 1 to the power 40, which is 1, equal to 2 times of what we wanted to get. We wanted to get this sum. So from here, can we say that x is 3 to the power 40 plus 1 by 2? So see, this basic question is getting related from just the expansion of binomial theorem, isn't it? The expansion of binomial theorem. Let's move ahead. The degree of polynomial. So these are the basic questions. So degree of binomial is what? Degree of polynomial is the highest power of x in the expression, in the polynomial. Expression is different in the polynomial. Like if we have fx equal to an x to the power n, a n minus 1 x to the power n minus 1, it will go dot 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 a1 x plus a naught. So highest power is here. So degree will come out to be n. Okay. So now in this expression, what will happen? So in the given expression, we have x plus x cube minus 1. So for instant, we'll consider this as y. So can we say that x plus y to the power 5 plus x minus y to the power 5. We are doing the expansion of this, and by the previous result we know that only the even power will be existing, isn't it? Only the even power on y will be existing, because odd power will get minus. So we can say that it's simply 5c0 y0, 2 times of 5c0 y to the power 0 x to the power 5, 5c2 y to the power 2 x to the power 3, 5c4 y to the power 4 x to the power 1. So these are the only term which is going to come. And if you see here, it is 2, 5c0 y to the power 0 is 1, so we have x to the power 5. Here we have 5c2. Y is what? X cube minus 1 by x cube minus 1 to the power 1 by 2. Whole square of that is what? X cube minus 1, and we have x cube here. And now we have 5c4 y to the power 4 is somewhere x cube minus 1 whole square, and we have x. If you see, from here we are going to get degree 5, from here we are going to get degree 6. So degree, okay. And from here if you see, the maximum degree is going to be x cube whole square, which is x6 into 1, which is x to the power 7. This is x to the power 6. This is x to the power 5. So can we say that maximum power existing in the polynomial is the highest degree of the polynomial? So we can say that degree of this polynomial is 7. Okay. Now we have this question. Okay. So if you see, this is 1 upon 1 factorial 10 factorial 1 upon 2 factorial 9 factorial 1 upon 3 factorial 8 factorial 1 upon 10 factorial 1 factorial. If you see that every term is summing up to 11, 10 plus 1 is 11, 9 plus 2 is 11, 8 plus 3 is 11, 10 plus 1 11. So every term coming here will be 11. So what will happen in this case? If we multiply with 11 factorial and divide with 11 factorial, can we say that it is 1 factorial, 10 factorial? This is 11 factorial, 2 factorial, 9 factorial, 11 factorial, 3 factorial, 8 factorial. If you keep on moving, can we say that it's 11 factorial, 10 factorial, 1 factorial? If you see it further, it is what? 1 by 11 factorial. And if you see, it is something written as 11C1. This is written as 11C2, 11C3. Similarly, it is written as 11C10. Okay. Now what will happen? We'll add one 11C11 and minus 11C11. Similarly, we'll add 11C0 and minus 11C0. So what is happening is that we are getting 1 upon 11 factorial, and we are getting 11C0, 11C1, 11C2, dot dot dot, 11C11 minus 11C11 is 1, 11C0 is 1. Okay. So what will happen? Now how to find the value of this one, isn't it? So if you see 1 plus x to the power n is what? nc0 x to the power 0, nc1 x to the power 1, nc2 x to the power 2, nc3 x to the power 3. If you keep on going, you are going to get ncn x to the power n. Now if you put x equal to 1, what will happen? Are we going to get 2 to the power n, which is what? nc0, nc1, nc2, ncn. Now if you see here, it is what? nc0, nc1, nc2, dot dot dot, ncn. So can we say that the value of this is nothing but 2 to the power 11? Yes. Hence can we say that it is 1 upon 11 factorial, 2 to the power 11 minus 2. Yes. Further, what can we do is that we can further make it somewhere 2 taken as a common, 2 11 factorial, 2 to the power 10 minus 1. So by comparing, can we say that k equal to 11? So simple. Let's move ahead. So this question is similar to previous question. I want you all to solve this. So kindly take some time and solve this. Okay. So I am giving you few seconds and then solve it. So I am starting. Okay. Those who could not solve it, they should take some time and then solve it. Okay. You see, this is minus 2k. Okay. In this, what will happen? It is k equal to 1 to 19, and we have here somewhere k factorial 19 minus k factorial, and we have minus 2 to the power k. If you remember, k plus 19 minus k is what? 19. So we'll multiply with 19 factorial and divide with 19 factorial. So our aim behind this is what? We are trying to create it in the form of NCR. Okay? So now what will happen? If you see, it is 19 CK minus 2 to the power K, and we have 1 by 19 factorial outside. Yes? So K is equal to 1 to 19. Okay? Now one thing I wanted to say you is that this is minus 2 to the power k. Can we say it is 1 to the power 19 minus k? And can we say that it is 1 upon 19 factorial into, it is starting from 19c1 to 19c9. So we'll add 19c0 minus 2 to the power 0 plus summation of k equal to 1 to 19 ck minus 2 to the power k minus we added this thing, we'll minus this thing. So this is minus 1. 19c0 is 1, minus 2 to the power 0 is 1. So further going, can we say that it is 1 19 factorial, and now it is 19c0 to 19c19. If you remember, and we have minus 1 here overall. If you remember, can we say that it is nothing but the expansion of 1 minus 2 to the power 19? This is the expansion of 1 minus 2 to the power 19, and hence can we say that it is minus 2 by 19 factorial, which is equal to minus lambda by 19 factorial. Can we say that lambda is equal to 2? Okay. So this is what I am trying to say, that from the basic formula we are getting some good quality question. Moving ahead. Now we have to find the following binomials. Okay. Explain the following binomials. So we simply know the expansion. We know that x plus root 2 to the power 5 is 5c0 x to the power 5 root 2 to the power 0 plus 5c1 x to the power 4 root 2 to the power 1, 5c2 x to the power 3 root 2 to the power 2, 5c3 x to the power 2 root 2 to the power 3, plus 5c4 x, this is what, x to the power 1 root 2 to the power 4 5c0 x to the power 5c5 x to the power 0 root 2 to the power 5. So this is the way expansion goes. I will try to show you the second expansion. It is 1 minus 3x squared by 2 to the power 4. It is 4c0. You remember that this is 1. So anything going to 1, power, any power to 1 is going to be 1 itself. So we'll try to focus on only this thing. So 4c0 minus 3x squared by 2 to the power 0. 4c1 minus 3x squared by 2 to the power 1. 4c2 minus 3x squared by 2 to the power 2. 4c3 minus 3x squared by 2 to the power 3. 4c4 minus 3x squared by 2 to the power 4. So this is the way the expansion is going to happen. Expand the given binomial up to 4 terms. So why I am taking these small basic examples? Because what is happening? Binomial expansion follows a specific sequence while expansion. See, for example, we have 2 upon x plus x 2 power 10. We'll have 10c0 and first power will be having what, 10 minus 0, which is 10. So we can't write this as 0, 2 by x to the power 0 and then x to the power 10. It is 10, then it will come 10, like 10 minus 0, it will come 10 minus 0 and it will come out to be x to the power 10, x to the power 0. This is 10 c1 2 by x to the power 9 into x to the power 1. 10 c2 2 by x to the power 8 x square. 10 c3 2 by x to the power 7 x cube. We are asking for just first 4 term. So this is 1, this is 2, this is 3, this is 4. Okay, so we are going through first 4 terms, isn't it? So first 3 terms in the expansion, we can follow the same thing what we followed that there. Expand this one, so same way. Now Pascal observation. So what will happen after expansion? What we might have thought is that we simply got it. If this is 1, x plus y to the power 0, x plus y to the power 1, this is what? 1, this is x plus y. So the coefficient of x is what? 1. Coefficient of y is what? 1. Now if you do x plus y whole square, we know that it is x square plus 2xy plus y square. So it is what? Coefficient of x square is what? 1. Coefficient of xy is what? 2. Coefficient of y square is what? 1. Now x plus y whole cube. It is x cube 3 x square y 3 x y square plus y cube. Can we say it is 1 3 3 1? Okay. So similarly now for x plus y to the power 4, can we say that it's 1 4 6 4 1? So similarly if you keep on moving, our observations are going to be the same. And you can say further that it is nc0, this is nc0 x to the power n, and this is nc1 x to the power n minus 1 y to the power 1. So n is also 1, isn't it? In this case you can say it is 2c0 x square y to the power 0, 2c1 x y, 2c2 x to the power 0 y to the power 2. Got it? Similarly this is 3c0 x cube, 3c1 x square y, 3c2 x y square, 3c3 y cube. Okay, so similarly we can have expansion. Okay, so let's move ahead. Now we are on the topic like the number of dissimilar terms. Dissimilar, okay. So how many dissimilar terms will come out? So if you see, it is simply 1 plus x to the power 4 minus 2 into x square to the power 15. So if you see, it is a square plus b square minus 2ab. So can we say that it is x square minus 1 whole square to the power 15? Can we say that it is x square minus 1 to the power 30? Okay. Now if you see, this expansion is going to be, so expansion of x square minus 1 to the power 30 is going to be like this: 30 c0 x square to the power 30, which is x60. Since it is minus, so it is going to be somewhere like this: 30 c1 x to the power 58 plus dot 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 30 c30 30 c30 x to the power 0 minus 1 to the power 30. So if you see that, we are going to have from 0 to 30. Yes, and all the powers are different, isn't it? So can we say that we have 30 plus 1, this similar term? Can we say that? So this is how it is going, okay? Now the coefficient of x to the power 6, y to the power 3 in x plus y to the power 9. Okay, so we'll find that any of the term. So it will be going somewhere 9c0, the term x plus y to the power 9 will go somewhere 9c0 x to the power 9 y to the power 0, 9c1 x to the power 8 y to the power 1. There will be some term where we are getting 9cr x to the power 9 minus r y to the power r. Okay, in between expansion we'll get some term like this, and we'll be having 9c9 x to the power 0 y to the power 9. So we are told that this is the term. So what is this coefficient? So this term should be equal to, if you see it is somewhere, we'll say this is alpha x to the power 6 y to the power 3. So by comparison can we say that, from here by comparison can we say that r is equal to 3, and hence we can say that coefficient of x to the power 6 y to the power 3 is 9c3. Okay, second, now in this expansion we'll tell that one of the term in the expansion will come out to be 12 cr a to the power 12 minus r minus 2b to the power r, and we have to compare this with alpha a to the power 5 b to the power 7. So can we say that if you compare, this is b to the power r, so r is equal to 7. So coefficient of a to the power 5 b to the power 5 b to the power 7 in the expansion is 12c7 minus 2 to the power 7. Can we say this? Okay, let's move ahead. The coefficient of x to the power 7 in this and x to the power minus 7 in this. Okay, and the relation between a and b so that coefficients are equal. Okay, we are told that coefficient of x to the power 7 is equal to coefficient of x to the power minus 7 in this. So for x to the power 7, we'll have 11 CR AX squared 11 minus R 1 by BX to the power R. If you further see, it is 11 CR A to the power 11 minus R into 1 upon B to the power R, and this is X square 11 minus R, and this will come out to be X to the power minus R. If you see it further, it is 11 CR A to the power 11 minus R upon B to the power R, and this is X 22 minus 2 minus R minus 3R. Okay, we are told that this power is X to the power 7. So if we equate 22 minus 3R equal to 7, we are going to get somewhere 15 equal to 3R. So R equal to 5. Yes. So this coefficient is what? If you see 11 C 5 A to the power 6 B to the power 5. Yes. Now we are moving with x to the power minus 7, which is what? 11 CR AX to the power 11 minus R minus 1 BX square to the power R, which could be further written as 11 CR A to the power 11 minus R B to the power R, and it is X to the power 11 minus R, and we have somewhere minus 1 to the power R, and we have X to the power minus 2R. Okay, so we are overall getting somewhere 11 CR A to the power 11 minus R B to the power R, we have minus 1 to the power R, and we have X to the power 11 minus 3R. We know that this power should be coming out to be X to the power minus 7. So we can say that 11 minus 3R is equal to minus 7. So can we say that R is equal to 6? So the coefficient will come out to be, this is minus 1 to the power 6, which is 1. Okay, so 11 C6 A to the power 5 B to the power 6, and we are told that these coefficients are equal. So can we say that 11 C6 A to the power 5 upon B to the power 6 is equal to 11 C5 A to the power 6 B to the power 5. Okay, so this is what it is. If you like to solve it further, so 11C6 and 11C5, okay, what will happen? It is 11 factorial, 6 factorial, 5 factorial. This is A to the power 5 B to the power 6, and it is 11 factorial, 5 factorial, 6 factorial, A to the power 6 B to the power 5. If you see this and this part getting cancelled, A to the power 5 A cancel, B to the power 5 B cancel. So we are simply getting AB equal to 1. So the relation coming out is AB equal to 1. Okay. The coefficient of x to the power 5 in the expansion. So till now we have just solved the simpler way. So now simpler equation. Now it's a complex, isn't it? So what will happen? We have 1 plus 2x to the power 6 and we have 1 minus x to the power 7. So can we say that the term coming out of this is 6c r 2 to the power 2x to the power r, okay, in multiplication with 7c r1 minus x to the power r1. Can we say this? Can we say further it is 6c r 7c r1 2 to the power r minus 1 to the power r1 is equal to x to the power r plus r1, and we know that it should come out to be x to the power 5. So r plus r1 is 5. So what are the possibilities? When r is 0, r1 is 5. So you should note that this r1 should be less than 7, less than equal to 7. When r is 1, r1 is 4. When r is 2, r1 is 3. Note, I am solving this considering you don't know permutation combination. Otherwise we have a simple way, okay, to find this. This is r equal to 3, r1 equal to 2, and this is r equal to 4, r1 equal to 1, and this is r equal to 5, r1 equal to 0. So now what? When r is equal to 0 and r1 is 5, we will have 6c0, 7c5, 2 to the power 0, minus 1 to the power 5, which is minus 1, 6c1, 7c4, 2 to the power 1, minus 1 to the power 4 is 1, 6c2, 7c2, 2 to the power 2, 5, it's 3, okay, so 3, okay, minus 1 to the power 3, 6c3, 7c2, 2 to the power 3, minus 1 to the power 2, okay, okay, so we have 6c4, 7c1, 2 to the power 4, minus 1 to the power 1, which is minus 1, 6c5, 7c0, 2 to the power 5. Now we have to add all these terms. Then only we'll get the coefficient of x to the power 5. So normally we will have to calculate the value and then add it. We have to calculate and then add it. So calculate it and get the value. Simple. 7c5 value put there, 2 to the power 0. It's all integer. Calculate and put there. So coefficient of x to the power 4. From the previous question we can do this. coefficient of x to the power 5 in the expansion. So what will happen? From here, the term coming out to the power of x to the power 5 is 21 c5. Here it will come out to be 22 c5. Okay. Or we can do some simple way. Okay. If we don't do this thing, okay, this is a GP with common ratio 1 plus x. Yes. So sum of these numbers are what? So if you find the sum, it is first term common ratio to the power total number of terms. So it's a 10 minus 1 upon r minus 1. If you see, it is nothing but 1 plus x whole power 21. And if you see the bottom, it is nothing but x. And if you see this, it is nothing but 10c0 x to the power 0, 10c1 x to the power 1, 10c2 x square plus dot 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 10c10 x to the power 10 minus 1. Isn't it? Now if you see further, it is 1 plus x to the power 21 and 10c01. This and this is going to be getting cancelled. We are left with 10c1. If we send x inside, it is 10c1, 10c2 x square, 10c3 x. It is x to the power 1 because we divided it with x. Okay. 10c4 x cube, 10c5 x to the power 4, 10c6 x to the power 5. Now whatever term we are getting, it is more than power of x to the power 6. So we don't require this thing. If this is multiplied to 1, we can get x to the power 5. But in this case we will not get it. So we are not going to look beyond x to the power 5. So now in this case, if you want to get x to the power 5, can we say it is 21c5 10c1? In this, can we say that it is 21c4? No, we are going to get x to the power 5. Yes. 4 10c2. This is 21c 3 10c 3 21c. It is 3 21c2 10c4 21c 1 10c5. You can have 21c 0 10c6. So this is what we are going to get. Okay. And now what? We'll expand it and try to find the sum. Right now we don't know this multiplication summation. We have not studied. That is why I'm not solving it using that trick. So I'm telling that we'll explain this way and we'll solve it. So you got it? So hello Harshit. Let's proceed ahead. In the expansion of x cube minus 1 by x squared to the power n, the sum of coefficient of x to the power 5 and x to the power 10 is 0. Then n is. So what will happen? The coefficient of x to the power 5. So the general term will come out to be NCR x cube n minus r into minus 1 x squared to the power r. So what will happen if you see it is NCR x 3n minus 3r. We have minus 1 to the power r x minus 2r. If you solve it, it is NCR minus 1 to the power r x to the power 3n minus 5r. Okay, so this has to be either x to the power 5, this will have to be x to the power 5, or x to the power 10. Like, so what will happen? We'll put 3n minus 5r equal to 5, and we'll put 3n minus 5r equal to 10. So this is what will happen when we are getting x to the power 10. Okay, now sum of the coefficient. So sum of the coefficient is what? NCR. NCR. So what will happen? In this case, R will come out to be 3n minus 5 by 5. NCR, okay? When we are finding coefficient of x to the power 5, isn't it? And this is minus 1 to the power 3n minus 5 by 5. Now we are doing sum with NC 3n minus 10 by 5 into minus 1 to the power 3n minus 10 by 5. It should be equal to 0. Okay, so we have to solve this. So we can simply say that if this is positive, this is positive, that means this is positive, then this is negative. Okay, so considering that, we'll send it like this: n factorial 3n minus 5 upon 5 factorial 3n minus 5 upon 5 factorial upon 5n minus 3 2n plus 5 upon 5 factorial. This is equal to n factorial 3n minus 10 upon 5 factorial, and we are getting 2n plus 10 by 5 factorial. Yes. So what can happen? We can't solve a lot. We will equate this with this one. Okay. If we equate this with this one, we are not getting any value, because what will happen? 3n minus 5 by 5 will be equal to 3n minus 10 by 5. So 5 cancel, 3n cancel. So minus 5 is not equal to 10. So we'll equate this with this one. So what will happen? Wait a second. So we'll equate 3n minus 5 by 5. So 3n minus 5 by 5 is equal to 2n plus 10 by 5. So if you solve it, 5 cancel, n will come out to be 15. So the value of n is 15. Okay. This is it. So I'm trying to take this question. So seventh term from the beginning to seventh term from the end. So seventh term from the beginning and seventh term from the end. Okay. So we can't. So we can simply say that. See, if you see, we have tr plus 1. Okay. So right now I'm not going like this. Okay. We have not studied the general term. So I'm not taking. So if you expand this one, we are going to get nc0 whole cube to the power n 1 by whole cube 3 to the power n minus 1. Okay. Or I'm saying you more general way. Okay. So I'm telling you more general way. Okay. If you take this LCM, can we say that it is 6 whole cube plus 1 to the power n, and we are getting 3 to the power 3 to the power n? Yes. So sixth term. So in this expansion we are getting nc0 6 to the power 1 by 3 n. First term. Second term is this. Yes. Third term will be 2. So when in third term will be 2, fourth term will be 3. So can we say that seventh term will be n minus 6 and dot 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 divided by 3 to the power n by 3. So seventh term, okay, seventh term will come out to be nc. It is nc0 n minus 0 nc6 nc6 6 to the power n by 3 minus 2 minus n by 3. Okay. So seventh term from and. Now what will happen if you remember? Seventh term from the end will come out to be ncn 6 to the power 1 by 3 into n minus n ncn minus 1 6 to the power 1 by 3. It will be 1 only. Okay, it will be 1. So for first term it is 0, for second term it is 1, for third term it will be 2. So ncn minus 1 is equal to nc1. Okay, this is 6 2 by 3. So similarly sixth term will come out to be nc6 6 to the power 1 by 3 1 1 by 3 2 1 by 3 2. Okay, it will come out to be 6 by 3. Okay, and then dot dot dot, and at the bottom we have already 3 to the power n by 3. So seventh term from the end is what? NC6 6 square 3 to the power n by 3. So both the terms we have to find the ratio, isn't it? Both the ratios. So both the ratios are somewhere 6 n minus 3. 6 minus 2 upon, no, it is 3 to the power n minus 2. Okay, we should note that. Okay, this is not minus n by 2 because it is 3 and we have the power of 6. This is divided by 3 to the power n by 3. So it's a better we write the same. Okay, what is given? NC6 6 to the power n by 3 minus 2 upon 3 to the power n by 3, and here we have NC6 6 square 3 to the power n by 3. So this and this getting cancelled, this and this getting cancelled. This is equal to 1 by 6. Okay, so if you solve it further, this is 1 by 6 square 6. So if you see, it is 6 to the power minus 1. So n by 3 is equal to 1. So n equal to 3. Okay, after solving you get n equal to 3. Okay, this is the very good question using Pascal theorem. Okay, so what will happen in Pascal theorem? You remember it is 1 1 1 1 2 1 1 3 3 1. Okay, so 1 4 6 4 1 1 5 10 10 5 1 1 6 15 20 15 6 1. If you see here, this is what 1 1 3 1 1 3. If you see, it is somewhere this, it is falling on this, and if you see the bottom, it is 1 6 15. So it is this. So it is cube 4 5 6. So can we say that it is 18 cube 7 cube plus 3, 18 into 7, 18 plus 7, which is written as nothing but 18 cube 3, 18 square 7, 3, 18 into 7 square plus 7 cube. So can we say that this is what? 18 plus 7 whole cube. Similarly, when you go, it is 1 6 15 20 15 6 1. So it is 2 to the power 6. So can we say that this expression is 3 plus 2 to the power 6, which is nothing but 5 to the power 6. This is 25 to the power 6, which is 5 to the power 25 to the power 3, which is 5 to the power 6. Can we say that this expression, the given expression, is nothing but 18 plus 7 to the power 3 upon 3 plus 2 to the power 6, which is nothing but it is 5 to the power 6 upon 5 to the power 6, which is 1. Got it? So we have 1 2 3. Okay. So try this question. I am giving you 1 minute and then we'll come to it. Try this question. Okay. So I think most of you might have tried this question, but they could not get it, isn't it? So simply see that in this expansion, we are going to have some term like 6561 CR. Okay. So 6R, and there will be something like 1 by 7 to the power 1 by 3, 6, 5, 6, 1 minus R, and it will be 11 to the power R by 9. So the term in the expansion would be somewhere like this. So can we say that 6561 minus R by 3 should be integer because radical free. Similarly, R by 9 should be integer because it's a radical free, isn't it? So now how to find it? Okay, so first we'll try to take R equal to 0. So if R is equal to 0, is this multiple of, is the, so if we put R equal to 0, we'll find the sum of this, and if the sum of this is divided by 3, then it's a multiple of 3. So 6, this is 6, 5, 11, 11 plus 6, 17 plus 1, 18. So this is divisible by 3. So we can say that R equal to 0 is correct. So R equal to 1, R equal to 0, now R equal to 9. So what will happen from this sum? This sum was going to be 18. This sum was going to be multiple of 3. In that multiple we are minusing 9. So that is again a multiple of 3, isn't it? So what will happen now? We got that now if you minus 18. So from sum which is divisible by 3, if we are minusing some sum which is again the multiple of 9, that is going to be multiple of 3. So I think this is going to be this way, and at the end we'll have to check greatest integer of 6561 by 9. So it is what? 9 7 ja 56, 9 7 ja 63, 9 2 ja 18, 9 9 ja. So R is 729. Okay, R is 729. So if you see, we have total 8 to the power 0, 9 to the power 0, no, 9 into 0, and 9 into 1, 9 into 2. So if you keep on moving, we have 9 into 81. So total terms are how much? Total radical free terms are 81 plus 1, which is 82. Okay, so this is the approach. This question you can solve by yourself. Quotient of x cube in the power is 0. So solve it by yourself. This question, solve it by yourself. This question I am helping you to solve. If you see, this question is somewhere 1 minus x square common 1 minus x whole power 6. This is further 1 minus x whole square to the power 6. If you see, it is 1 minus x whole square 1 minus x to the power 6. If you see further, it is 1 minus x to the power 12 into 1 minus x to the power 6. Now term coming out of this will be 12cr minus x to the power r, and terms coming out of this is 6cr1. This is plus, yes, x to the power r1 according to us. So overall term is going to be 12cr 6cr1 minus 1 to the power r x to the power r plus r1. We want r plus r1 to be 7. So what will happen? R1 could be maximum, this R1. This R1 could be maximum 6. So when R1 is 6, this is 1. When R1 is 5, this is 2. When R1 is 4, this is 3. When R1 is 3, this is 4. When R1 is 2, this is 5. Okay. When R1 is 1, this is 6. When R1 is 0, this is 7. So based on that, we have all earlier did such type of question. So when R1 is 6, so it is 6C6, which is 1. So we will see here, okay, we are going 12C1 6C6 minus 1 to the power 1. We have 12C2 6C5 minus 1 to the power 2, which is 1. So 12C3 6C4, this is minus 1. 12C4 6C3 12C5 6C2 minus 1. 12C6 6C1, this is plus 1. 12C7, this is minus 1. Okay, so we'll add all of them and we'll get the coefficient of x to the power 7. Moving ahead, solve this. Solve this. Now we are coming to general term. So from the previous examples, I think if you have gone through them very nicely, your general term is done. But still I am trying to give you some overview. Okay. So general term will what happen? If we have 1 plus x to the power n, we are getting what? nc0 x to the power 0. if it is 1 and this is x, and c1 x to the power 1, let's keep it y, okay, y to the power n, y to the power n minus 1, and c2 y to the power n minus 2, x to the power 2. If you keep on going dot dot dot, we are getting ncn y to the power 0, x to the power n. Okay, now if you see, if this is first term, can we say that it is first term is this, okay, so if this is first term, we are doing first minus 1. If this is second term, so this is 2 minus 1. Yes, so if you see the general term t r plus 1, so if you say that r is 0, then we are getting first term. So r is 0 in the sense we can say it is ncr y to the power n minus r x to the power r, because for the first term we are getting 0. Okay, so if r is 0, we will get first term, and first term is what, nc0 x y to the power n x to the power 0. Similarly, if we see t1 plus 1, the second term, we have to simply do nothing, but we'll do nc1 y to the power n minus 1 x to the power 1. If I tell you t5 plus 1, what will happen? We'll simply write this is sixth term, which will come out to be nc5 y to the power n minus 5 x to the power 5. So these are the general term, okay. Okay, so if I give you one example, it is 1 plus 7x to the power 10. I am telling find fifth term. So we know that general term is what? General term, which is t r plus 1, which is equal to 10cr 1 to the power 10 minus r and 7x to the power r, and r is what? It's the fifth term, that means r is 4. Can we say it is 10c 4 7 to the power 4 x to the power 4 1 to the power 6. So this is the way we will find any general term, okay. Let's proceed ahead. 15th term in the expansion. 15th term in the sense 14 plus 1. So we'll do 20c14 2x to the power 20 minus 14 minus 3y to the power 14, which is 20c14 2 to the power 6 x to the power 6 minus 3 to the power 14 is 3 to the power 14 y to the power 14, which is 20c14 2 to the power 6 3 to the power 14 x to the power 6 y to the power 14. Second term, fourth term, which is what? t3 plus 1, which is 7c3 3x by y, 3x by 5 to the power 7 minus 3 minus y to the power 3. If you see, it is 7c3, 3x by 5 to the power 4 minus y whole cube. 7c3, 3 by 5 to the power 4 minus x to the power 4 y to the power 3. Okay. So rational term in the expression, we have already gone through this question. Second term, third term, fourth term are like this. Solve for n. So second term is 1 plus 1, which is nc1 x to the power n minus 1 into a to the power 1. Third term is 2 plus 1 nc2 x to the power n minus 2 a square. Fourth term 3 plus 1 is what? nc3 x to the power n minus 3 a cube. So the terms are 240, 720, 1080. If you divide, we are going to get the term of n and ax. Okay, let's divide this and this. We are going to get nc1, nc2 x upon a equal to 1 by 3. And if you divide second and third, we are going to get nc2, nc3 x upon a, which is 24 threes are. Hello Yugandhar, hello. I am fine, okay. So 24 threes are, and it is 12 sixes are, okay. 12 sixes are, 12 nines are. Okay. So from here, if you see nc1, 3 times of nc1 into nc2 is equal to a by x. And if you see 3 by 2 times of nc2 upon nc3 is equal to a by x. So both are equal. Can we calculate the value of n? So it is simply nc1, 3 times of nc1, nc2 is equal to 3 by 2 times of nc2, nc3. So 3 cancel. It is 2 times of n. nc1 is n, nc3 is n factorial, 3 factorial, n minus 3 factorial, which is equal to n factorial, n minus 2 factorial, 2 factorial, n factorial, 2 factorial, n minus 2 factorial. So what will happen? Let's solve it further. We have 2 n minus 1, n minus 2 upon 6. So this will come out to be n minus 1, n minus 2, n minus 3 factorial. So n minus 3 will get cancelled. Okay. This is n n minus 1 upon 2. This is n minus 1 upon 2. So what will happen if you see n minus 1 and n minus 1 and they are getting cancelled. So we could have told that n is equal to 1, n is equal to 0. But what is happening if we are getting second, third, fourth term? Then n cannot be less than, at least n should be 3. N should be 3. Okay, at least n should be 3 or more than 3. So n is equal to 1, n equal to 0 is not possible. Again we'll cut this and this. 2 3s are. So if you solve this further, we are going to get 4n minus 8 equal to 3n minus 3. So we'll get n equal to 5. Okay, so n is equal to 5. Second term in the expansion is this, then the value of this. So we'll find the second term. So second term in the expansion. So second term meaning t1 plus 1, which is nothing but nc1 a to the power 1 by 13 n minus 1 into, this is a to the power minus 1 by 2. When it will go up, it is it is somewhere a to the power 3 by 2 into 1. Okay, and this will have to be equal to 14 a to the power 5 by 2. So this is n, this is a, n by 13 minus 1 by 13, 3 by 2 will go this side. Okay, so it will become 14a. If 3 by 2 will come this side, it is 5 by 2 minus 3 by 2, which is 2 by 2, which is 1. That means what will happen if you see this is 1. So n by 13 minus 1 by 13 equal to 1. So n is coming out to be 14. From this comparison also, and from this comparison also. So n is 14. Now we have to calculate 14c3 upon 14c2. We can simply write 14 factorial upon 3 factorial 11 factorial into 14 factorial 2 factorial 12 factorial, which is nothing but 14 cancel. We are getting 12 by 3, which is 4. Okay, so right now we have not reached to the properties of coefficient, because we can solve this simply by properties of coefficient. So 11 terms with the expansion. I am helping you to solve this question. So T11 is nothing but 10 plus 1. Okay, and before that, if you try, before that I am taking 3 minus root 17 by 4 plus 3 root 2 to the power 15. I am trying to simplify this thing. Okay, so this is what 3 minus, if you try to see, divide 2, multiply 2, and if you see 17 by 4 is nothing but 3 by 2 whole square plus root 2 by root 2 whole square. So this is a square plus b square plus 2ab, and this is to the power 15. If you go further, you'll find 3 minus root under 3 by 2 plus root 2 whole square to the power 15. If you go further, it is nothing but 3 minus 3 by 2 minus root 2 to the power 15. If you solve it further, it is nothing but 3 by 2 minus root 2 to the power 15. Okay? Now we have to find 10th, the 11th term in the expansion. It is something like 15 C10 3 by 2 to the power 15 minus 10, which is 5, and minus root 2 to the power 10. Can we say it is 15 C10 3 by 2 to the power 5 into 2 to the power 5, which is nothing but 15 C10 into 3 to the power 5. This is what it is. Coefficient of m, so you should be solving this by yourself. This you should solve by yourself. This you should solve by yourself. Okay? There is no rocket science in this. There is no rocket science, okay? If you want, I can solve this, okay? The number of values of x for which, okay? So if you saw, see, it is 5 log 5, 4 to the power x plus 44 to the power 1 by 2 into 2 by 5. It is this plus 1 upon 5 to the power log 5 and whatever term is there, okay? So what will happen if this 5 and this base is same? This term will come down, okay? So here also what is happening? This term is coming down. It is 4 to the power x plus 44 to the power 1 by 5, and if you see here, it is nothing but 1 upon 2 to the power x minus 1 plus 7 to the power 1 by 3. Now 8. We have to find the fourth term in the expansion. So fourth term in the expansion is nothing but t3 plus 1. So it is 8c3. Okay. Now 4 to the power x plus 44 to the power 8 minus 3 by 5 into 1 upon 2 to the power x minus 1 plus 7 to the power 1 by 3, 3 by 3. It is equal to 336. If you go further, if you find it is 8 factorial, 5 factorial, 3 factorial, and this is nothing but 4 to the power x plus 44, and this is nothing but 2 to the power x minus 1 plus 7 equal to 336. If you solve it, it is 8, 7, 6. 5 factorial cancel, 3 factorial, 6 cancel. This is 56, 6 ja. So if you go further, it is nothing but 2 to the power x whole square plus 44 equal to 6 into 2 to the power x upon 2 plus 7 into 6. If you take it, it is t square minus 3t plus 2 equal to 0. So we are going to get t equal to 1 and 2. So t is what? 2 to the power x equal to 1, 2 to the power x equal to 2. So x is 0 or 1. So can we put x 0? It is 45. Okay, x 0 is correct. Yes, x to the power 0, x to the power 1. So both x could be 0 or 1. So we have two possibilities for x. This you solve by yourself using the previous, and this you solve using the previous. Okay. Now terms independent of x. Okay. What will happen? We'll take some binomial. So term independent of x is the term whose power of x is 0. This is the term independent of x. Okay. So I am taking one example. If we have x to the power a, y, z, x to the power b, y, alpha, and this is n. We have to find the term which is independent of x. Find the term which is independent of x. So we'll find a general term tr plus 1, which could be written as ncr x to the power a y n minus r z upon x to the power b y to the power alpha to the power r. Okay. In this, if you see ncr y to the power n minus r z to the power r y to the power alpha r, these are okay. Now we have x to the power a n minus r, and this is x to the power minus br, isn't it? If you see further, this term is same, and we have x to the power an ar minus br, which should be equal to x to the power 0, some constant into x to the power 0. So we can say that an minus ar minus br should be equal to 0. By this we can say that r should be an upon a plus b. So the term which is independent of r will be nc an a plus b y n minus an a plus b z an a plus b upon y a into an a plus b. So this is the term which is independent of x, isn't it? So in this we have to find the term independent of x. So it is better to make this thing a bit simpler. So x to the power 2 minus 1 upon x to the power 6 to the power 16. We can make it x to the power 8 minus 1 to the power 16 upon x to the power 96. Okay, so what will happen from here? We'll get some general term, which is what? 16 cr minus 1 to the power r, x to the power 8 16 minus r, and we have x to the power 96. So we'll try to make this power equal to 0. So if you see, it is something 8 into 16 minus r minus 96 should be equal to 0, which is what? 16 into 8, 128 minus 8r minus 96 should be equal to 0. If we go further, it is nothing but 32 equal to 8r. So r is equal to 4. So the term which is independent of r is t4 plus 1. That means fifth term is going to be independent of x. Now the term independent of x in this. So what will happen if you see? If you see this term, it is nothing but x to the power 1 by 3 plus 1 a plus b into a square plus b square minus ab. Okay, this is a cube plus b cube, which is a plus b into a square plus b square minus ab. And in division, if you see, we have x to the power 2 by 3, x to the power 1 by 3 plus 1. This and this getting cancelled. And if you see here, in the second one, we have nothing but x to the power 1 by 2 minus 1, x to the power 1 by 2 plus 1. And here we have x to the power 1 by 2, x to the power 1 by 2 minus 1. This is whole power 10. This and this going to be cancelled. So overall, if you see, it is something x to the power 1 by 3 plus 1 minus x to the power 1 by 2 plus 1 upon x to the power 1 by 2 to the power 10. If you see, it is x to the power 1 by 3 plus 1 minus 1 upon x to the power 1 by 2 to the power 10. If you see further, it is nothing but x to the power 1 by 3, 1 cancel. This is minus 1 upon x to the power 1 by 2. So in the expansion, now in the expansion, we'll find tr plus 1, which is nothing but 10cr x to the power 10 minus r by 3 into minus 1 minus 1 to the power r, and we have x to the power minus r by 2. So here if you go further, it is 10cr minus 1 to the power r. It is x to the power 10 minus r by 3 minus r by 2. So what will happen? This will have to come out to be x to the power 0. So we'll do it simply 10 minus r by 3 minus r by 2 equal to 0. If you solve it, it is nothing but 20 minus 2r minus 3r equal to 0. So r equal to 5. So our term is going to come out as T6, which is nothing but 10C5 2 to the power 5 by 3 and minus 1 to the power 5, which is minus. So this negative term will come out to be the solution for this. Okay, the terms independent of x in the expansion. So what will happen if you go through this term? It is somewhere 3 by 2 x square minus 1 by 3x to the power 9 plus x 3 by 2 x square minus 1 by 3x to the power 9 plus 2x cube 3 by 2 x square minus 1 by 3x to the power 9. Now the coefficient which should come out of it, which is independent of x, is 9cr 3 by 2 9 minus r x square 9 minus r minus 1 by 3 to the power r, it is x to the power minus r, plus now here we have x. Okay, so we'll have something the same term multiplied with x. Okay, so what will happen, we'll wait, we'll not go for this and this, we'll wait right now. Okay, if you see here, it is 9cr, this is 3 by 2 9 minus r, and we have minus 1 by 3 r, and we have x 18 minus 2r minus r. Okay, now in this case it will come out to be r plus 1. In this case it will come out to be r plus 3 because it's a 3. So for the first term we should be getting 18 minus 3r equal to 0, that means r equal to 6. For the second expansion we should be getting 18 minus 3r plus 1 equal to 0. Okay, 18r plus 1 equal to 0. So we'll find that it's something like 19 by 3, which is not equal to integer. So no possibilities. Okay, so there is no possibilities in the second case. We'll get any term which has x with some power. In third, we'll get 18 minus 3r plus 3. So from here we'll get r equal to 7. Okay, so now what will happen? First term will give you some output. The output of first term is 9, r is 6. R is 6. Okay, 9c6 3 by 2 to the power 3, and this is minus 1 by 3 to the power 6. Second term will give you 0. Third term will be giving you the value 2 into 9c 7 3 by 2 to the power 2 minus 1 by 3 to the power 7. Now we'll add all the term. It is something 9c6 1 by 6 to the power 3 plus 2 into 9c7 1 by 2 square into minus 1 by 3 to the power 5. So this is the coefficient, okay, whose expression will be independent of x. Moving ahead. So we are on lecture 2 and we are near to 1. Okay. So we'll start lecture 2 with 15 minutes of break. We will come back at 1:15 p.m. Come back, okay? We'll come back at 1:15. Okay. We'll come back at 1:15. यार तेरे का कुछ करना है कहाँ डालता है तेज पता है नहीं मतलब तेज पता हमारी लाइंस की हमारी बात को दिख रहा है तो चले गया अभी मिक्सर में ले ये कटोरा धो के देखना था कौन था कटोरा धोया हुआ कोई ऐसे नहीं रखा होगा अब तो सुबह सुबह भूख लग गया इसको नहीं हम उठे हम लेकिन क्या कर रहे हैं खाना बनाए नहीं हम आप बनाइएगा लेट से हम बना देते हैं नहीं हम लेट टाइम ना बनाइए हम बना देंगे आप यहाँ बना देंगे इसमें तो मंडे से तो नहीं बनाना होगा मंडे से आलू का ये क्या है धीरे से करके फिर गिरलिएगा उसका घी ले हाँ उसका घी पूजा की है क्या है भगवान क्लास आपका और बाकी है ऑन ही क्या लाइव पॉज में वो देखेंगे ना हम दूसरे साथ में आपने साथ फ्रेंड्स आप दिखा दीजिए तब कंबल डाल दें हाँ नहीं आता अरे और कंबल का तो ना निकाल के डालना है हाँ इसको डालना है बुलाने वाला आपको कौन सा संकार की बात और बुलाया है हमको नहीं है आया होगा तो चेक नहीं करता ऑप्शन दे चेक नहीं करता ये तो चैनल नहीं है यही चैनल नहीं है So, how was your break? We are back again. So now we are going with middle term. Okay. So in middle term, what will happen? In the expansion, we have to find the middle term when we are expanding something. So we have to find the middle term. Okay. So what will happen if I am saying you the middle term? So if we have x plus y to the power n, okay, we'll take if n is even. So what will happen if n is even? So total numbers of the term will be n plus 1, whether n is even or odd. Total number of terms are n plus 1. Okay. In case 1, case 1, when n belongs to even, when n is even, so n plus 1 will be odd. So what will happen? N plus 1 will be odd. So can we say that middle term will be a single term? Middle term will be a single term. That means if it is a middle term, there will be n by 2 term, n by 2 term. If here it is a single term, there will be n by 2 term and there will be n by 2 term. So can we say that t n plus 2 plus 1 is the middle term? And when we have case 2, if n belongs to odd, if n is odd, so n plus 1 will be even. Yes, that means what will happen in this case, we'll have n plus 1 by 2 and n plus 1 by 2 terms. Okay, got it? So this is n by 2 plus 1th term, isn't it? So can we say that this is t n? So it is t n minus 1 by 2. So this is n plus 1 by 2 term. Yes. So r plus 1, this is r. We can simply say it, wait. This is n by 2 term, like 1, 2, 3, 4, 5, 6. So it was n was odd, so we have two middle term. One is this, one is this. Okay. So one term will come out to be t n plus 1 by 2 and one term will come out to be t n plus 1 by 2 plus 1. This is what I am trying to say. Or you could simplify this as t n minus 1 by 2 plus 1 and t n plus 1 by 2 plus 1. Okay. Okay. So we have two middle terms. Got it? Let's move ahead. Find the middle term in the expansion. So if you see the first question, 12. 12 belongs to even. So we will be having only one middle term, which is uh 662, which is t n by 2 plus 1. Do you remember? N by 2 plus 1. If you see the formula, this is n by 2 plus 1. Yes. So this is t 6 plus 1, which is nothing but 12 c 12c 6 and 2x to the power 6. This is the middle term. Second, middle term in the expansion of this one. Okay. So 11 belongs to odd. So middle term will come out to be t n minus 1 by 2 plus 1 and t n plus 1 by 2 plus 1. Okay. So if you go by any of the number, I think we are going to get the same result. Okay. Or let's see what is the result. For this one, we are getting 11. N is 11, which is 5. 11 minus 1, 10, 10 by 2, 5. So it is 11 C5 2y to the power 6 minus y square by 2 to the power 5. Okay. And from here we get 11 C 6 2y to the power 5 minus y square by 2 to the power 6. So they both are the middle term. Okay. Let's move ahead. Middle term in the expansion of. Middle term in the expansion of. So 7 belongs to odd. Okay. So middle term is t n minus 1 by 2 plus 1 t n plus 1 by 2 plus 1. Okay. So if we try to find this thing, n is 7. So 7 minus 1, 6. 6 by 2, 3 plus 1, and this is t 4 plus 1. So this is simply 7c3 x by y to the power 3 minus y by x. This is power 4. 7 minus 3. This is 3. Okay. And this is 7c4 x by y to the power 3 minus y by x to the power 4. Okay. So these are the things. Okay, if we go with second question, we can you find this? It is simply written as x minus 1 whole square to the power n. In case it would have come out in three format, okay, 1 to 3, we'll try to make convert this into two format, like two variable format, because we have learned to find the middle term of only two binomial. It's not trinomial, it's a binomial, isn't it? So we are trying to make it binomial. Okay, so it is something x minus 1 to the power 2n. Now if you see 2n is even, so middle term will come out to be t 2n by 2 plus 1, which is nothing but tn plus 1, which is 2n cn minus 1 to the power n x to the power n. Okay, so this is it. Prove that coefficient of middle term of the expansion of this is equal to the sum of coefficient of middle term of this. We are told that middle term of 1 plus x to the power 2n is equal to sum of middle term of 1 plus x to the power 2n minus 1. So middle term of this is what? 2n c n, isn't it? Because we know that 2n by 2, this is what? And middle term of this is 2n minus 1 c. 2n minus 1 minus 1 by 2, which is n minus 1 plus 2n minus 1 c n. This is it. If you try to solve this thing, it is nothing but 2n minus 1 factorial, n minus 1 factorial, n factorial, and this is 2n minus 1 factorial, n factorial, n minus 1 factorial. Okay, so if you see, uh, this is 2n minus, okay, we have t n minus 1 by 2, which is 2n minus 1 by 2 plus 1, and we have t 2n plus 1 n minus 1 plus 1 by 2 plus 1, n plus 1 by 2 plus 1, n minus 1 by 2 plus 1. This is what we have. So we are getting what? N minus n. From here we are getting n. So this is what? Prove that the expansion is the sum of the. This is what? 2n factorial, n factorial, n factorial. We are getting 2 to the power 2n minus 1 factorial, n minus 1 factorial, n factorial. Wait a second. Middle term of the expansion. So we should have gone through the basics. Okay, basic in the sense we should not directly become like hero. Okay, we should go through the basics. So if we don't go through basics, we'll face problem like this only. Okay. The coefficient of middle term. So middle term for even 2n belongs to even. So this is our basic. 2n belongs to even. Then we have what? N by 2 plus 1, which is what? 2n cn x to the power n. 2n minus 1 belongs to odd. So middle term is what? T n minus 1 by 2 plus 1, and we have t 2n minus 1 plus 1 by 2 plus 1. So this will come out to be 2n minus 1 cn minus 1, and this will come out to be this x to the power, if it is n minus 1, this will come out to be n, and this is 2n minus 1 cn is x to the power n minus 1. Okay, now we are told that if we do this sum, the coefficient of middle term. Okay, so these are the middle terms. So we have to tell that 2n minus 1 c n minus 1 plus 2n minus 1 cn is equal to 2n cn. We have to prove. Okay. Okay. My question is why to solve it like this? If you know Pascal formula, if this is x plus y to the power 2n minus 1, x plus y 1 2 1. If this is this, the sum of middle term is this, which is this. Using Pascal theorem, can we say this? That in odd, this is odd, odd has 2 and even has 1. So 2 is going to converge into 1 only. Okay. So when we solve this thing, let's solve it. Okay. By mathematically, if we solve it, is 2n minus 1, n minus 1, n factorial. It is 2. How to make it? So we have to multiply n and divide n. So it is 2n factorial upon n factorial, which is 2n cn. So we got it, proved it. So mathematically also we proved, and this we also we proved. Now middle term in the expansion. So 8 belongs to even. So middle term is what? T 8 by 2 plus 1, which is T 4 plus 1, which is nothing but 8 C4 K by 2 4 2 to the power 4, which is 1120. So we got somewhere 8 7 6 5 4 factorial upon 4 factorial, and we have k to the power 4 equal to 1120. Solving it further, 4 factorial cancel, 6 4 ja 4 2 ja, 4 factorial is 24, so 6 4 ja 24, 4 2 ja, so we are getting 70. 70 into k to the power 4 equal to 1120. So we can say k to the power 4 is 16, I think, and k is equal to 2, and k is r plus. So k could be plus minus, but k is r plus, so k is 2. So I think we got the middle number concept. So number of irrational term we have already solved in previous example, previous to previous examples. Okay, okay. And middle term is irrational, so middle term we have to search. Ninth term is rational, so we know this thing, we know this thing. The number of rational terms, we know this thing. Okay, so I am just solving middle term. Middle term will be what? It is n 20c. Middle term will be 20c 10, 4 to the power 3 by 10, 10 by 3, and 1 by 6 to the power uh, 10 by 4. So this is irrational. Okay, let's move ahead. Numerically greatest term. Okay, so now we are on the stage of numerically greatest term. Okay, so we want to go through the basics. Basic in the sense we want to go through the feelings of the question. What will happen if we have any function like x plus y to the power n? We'll try to pull y outside, and we'll get x by y plus 1 to the power n. Yes. Second, we have x cube y plus 1 upon y is cube x to the power n. We'll try to pull y 3n x to the power n, and we'll make it x4 y4 plus 1 to the power n. Now when we expand this and this, we are going to have the general any term will be somewhere like this: ncr x by y to the power r, any term. Okay, any term will be like 1 by y 3n x n ncr x to the power 4 y to the power 4 r. Yes, so this is going to appear with every term. This is going to appear with every term of this expansion. Okay, so now what will happen in this expansion? One of the term, one or more of the terms are greater than in the expansion. In the expansion, if we do mod of tr plus 1 upon tr, which will be greater than equal to 1, and t r plus 1 upon tr plus 2 will be greater than equal to 1. Okay, now tr plus 1 term is what? ncr x to the power. So what will happen? This single term will complete, will take at as some single variable. So x to the power r, and we have mod of this, yes, mod of this, which is n c r minus 1, x to the power r minus 1 bigger than equal to 1. If you solve it further, it is n factorial r factorial n minus r factorial n factorial. This will come out to be x, okay, mod x, n factorial r minus 1 factorial n minus r plus 1 factorial. This should be bigger than equal to 1, okay. And if it will happen, if you cancel, this is getting cancelled, this is cancelling this factorial, this is cancelling this factorial. So if you see, it is simply n minus r plus 1 upon r mod x bigger than equal to 1. If you try to solve it further, it is n plus 1 mod x, it is r mod x plus r. We are getting n plus 1 mod x upon 1 plus mod x, okay. Now while solving this equation, in place of r we have kept r plus 1. So can we say that n plus 1 mod x 1 plus mod x r plus 1, which is minus 1, r is less than equal to this thing. So if we go with this case is itself validated. So we should remember this formula now, okay. If we remember this formula, we can get directly numerically greatest term, okay. So numerically greatest term, so we know that in this expansion what we did, we told that we'll pull 7 out and we'll make it like 1 minus 3x by 7 to the power 25. Now using greatest term formula, we have got n plus 1 mod x, n is 25 plus 1 into mod x is this thing, yes, 3x by 7 upon 1 plus mod x minus 1. So r should be less than equal to that, okay. So what will happen now, we are getting 26 and x is equal to 1 by 3. So it's what, 1 by 7, this is 1 by 3, 1 by 7, 8 by 7 minus 1 less than equal to 4. If you solve it further, 7 7 cancel, 18 by 8, r is less than equal to 18 by 8. 18 by 8 is 2 point something, so r is what, 2. So if you see, the numerically greatest term is third term, isn't it? Third term is the numerically greatest term, okay. Moving ahead, numerically greatest term in the expansion of this. So apply the same formula, n plus 1 mod x upon 1 plus mod x minus 1 r is less than equal to that, we'll pull 3 outside. We are getting minus mod x is equal to what? So in this place of mod x we'll write mod 5 1 by 5 by 3, which is 1 by 3. Yes. So if you put here n is 15, so 16 into 1 by 3 plus 4 by 3 minus 1 less than equal to r. This is simply 3. R is equal to 3, which is r is 3. So we can say t 3 plus 1. That means fourth term is numerically greatest. Going with the second, the term which is numerically greatest. So what we told, now we are getting two variable. So we'll pull 2 to the power x outside. Now we are getting 1 plus 5y 2x to the power 34. So our greatest term formula is what? N plus 1 into mod this thing. Mod of this is what? 5 into y is 2, x is 3. Okay, which is nothing but 5 by 3. So we'll add 1 plus 5 by 3 and we'll do minus less than equal to r. So we are going with 35 5 by 3 8 by 3 minus 1 less than equal to r. So 3 gone. So what will happen? Now we have to calculate this thing. 5 5 are 25, 5 3 are 15 to 17 upon 8 minus 1 less than equal to r. So 8 2s are 16, 8 1 point something. So 21 point something minus 1 is less than equal to r. So we can say that r is, this is second part, okay, r is less than equal to 20 point something. So r is 20. So we can simply say 34 c 20, okay, and 2x to the power 14 and 5x to the power 20. And if you substitute the value, it is simply 34 c20, it is 6 to the power 14, 10 to the power, no, it's x is 3, y is this is y, yes, this is y is 2, 10 to the power 30 20, 10 to the power 20. So this is it, okay. Now this is star mark question. This is star mark question. We studied numerical greater. Now we have to study binomial greatest. So we studied that binomial greatest coefficient. If you go through Pascal's triangle, one, 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 two, one, one, three, three, one, one, four, six, 4, 1. You will find that the middle term is coming out to be the maximum. So middle term in even is what? 6c 3 n by 2. Yes, the middle term is what? T 6 by 2 plus 1, which is 63 into 2x to the power uh, 3 minus 5 to the power 3. So binomially greatest binomial coefficient is this thing, okay, which is middle term, okay. Second, now we have to go with greatest numerical coefficient, okay. So greatest numerical coefficient will go with this thing, okay. Tr plus 1, Tr is bigger than equal to 1, and Tr plus 1 upon Tr plus 2 bigger than equal to 1. It is mod, okay. So what will happen from here? We are getting what? We are getting NCR, okay, and it is uh, if we take 5 outside, okay, we are getting 2x by 5 upon NCR minus 1, which is equal bigger than equal to 1 mod x. This is mod x, okay. If you solve it, what we got was n plus 1 mod x, which is mod x 2 by 5 upon 1 plus. So what will happen in this place? We are getting this mod x 2 mod x by 5, isn't it? Let's give it some space, okay. So what will happen in this? We are going to get n plus 1 mod x 1 plus mod x, okay, and mod x is nothing but 2x by 5, which is 2 by 5, and we have 2 by 5. This is minus 1. R R will go this side, it will go, okay. R is less than equal to, okay. So here we don't know x, okay. So if we put x equal to 2, we don't know x. So while finding in this case, okay, what should we keep as x? We'll keep x equal to 1, okay, x equal to 1, because it will come out to be 3 to the power 6. Hmm. We'll put x equal to 1, okay. We'll put x equal to 1 if nothing is given, okay. So we are getting simply 6 plus 7, 7 into 2 by 5 upon 1 upon 2 plus 5, 7 by 5. So minus 1, r is equal to 1, r equal to 1, okay. And when we go by this way, we are going to get NCR 2x by 5 to the power 2x to the power r upon NCR minus 1, NCR plus 1, 2x by 5 to the power r. So at that time what we did, we in place of r we kept r minus 1, but we did not change the power of x, if you remember. So that was our mistake. So if you go from here, we have simply, from here we are going to get, it is n factorial r factorial n minus r factorial, and we have n factorial r plus 1 factorial n minus r minus 1 factorial, and at the bottom we have 2x by 5. So this is the mistake we made in previous question, okay. So if you go it further, it is second question. We are getting n cancel, it is r plus 1 n minus r, and this is 2 mod x by 5. So this is not minus, okay, this is 1 only, okay. So r is 2, r is less than equal to 2. So if you solve it normally, let's take it, okay. It is n is 6, so 5r plus 5, 12 mod x minus 2 mod x r will go like this, r 5 plus 2 mod x bigger than equal to 12 mod x minus 5. So if you see, r is bigger than equal to 12 mod x minus 5 by 5 plus 2 mod x. If we do x equal to 1, we are going to get r bigger than equal to 1. Yes. So r is 1 also, r is 2 also. Okay. R is 1 also, r is 2 also. R is less than equal to 1, r is less than equal to 2. That means we have two terms which are numerically greatest. Okay. Hello sir. Good afternoon sir. Yes sir. Sir अभी तो इधर ही है. सर तो आ सकते हैं अभी 7 बजे निकल जाएंगे, 7 बजे 6 बजे ड्यूटी से 6 बजे निकल जाएंगे और 1 घंटा पेपर डिस्कस करके आ जाएंगे. ओके सर. ओके सर. ओके सर. थैंक यू. So we are getting two terms, okay, two terms which are greatest. So what will happen? It is r1, r equal to 1. So can we say that 6c 1 2x to the power 5 minus 5 to the power 1. This is the one term, and second term is 6c2 2x to the power 4 minus 5 to the power minus 5 to the power mm, 2, 2. Yes. So these are the two terms which are greatest. Now if you see, you will find that one is negative and one is positive. So both are equal. Both are numerically greatest. But this is algebraically least because it is negative, and this is algebraically greatest. Understood? So that is how. So this is the answer for question number 3, and this is the answer for question number 4. Got it? So let's move ahead. So that was very good question. And now this is simple expansion. So we'll try to eliminate our doubt. Tr plus 1 Tr, which is bigger than equal to 1. So which is nothing but 9 Cr 3x by 2, 3x by 2 to the power r, and this is 9c r minus 1 3x by 2 r minus 1. Okay, this is greater than equal to 1. So this is nothing but 9 factorial r factorial, 9 is minus r factorial, and this is 3x by 2, and this is 9 factorial r minus 1 factorial 10 minus r factorial, which is greater than equal to 1. If you go further, it is 9 factorial, 9 factorial, done. We are getting r here, okay, and we are getting 10 minus r here, and this is 3x by 2, which is bigger than equal to 1, है ना? So if you see it, it is simply at x equal to 3 by 2, x equal to 3 by 2. So it is 9 by 4, 9 by 4 10 minus r upon r is bigger than equal to 1, or it's a 90 minus 9r bigger than equal to 4r. So we can say 90 by 30, r is less than equal to this. So r is less than equal to 6 point something. So r is 6. Okay. And similarly, if we go with the second condition, which is tr plus 1 upon tr plus 2 is bigger than equal to 1. Okay. So if we go through that way, we have somewhere, if you remember, it was ncr 9cr 3x by 2 to the power r, and we have 9c r plus 1 3x by 2 to the power r plus 1 is bigger than equal to 1. Solving it from this way, we are going to get r factorial will come down r plus 1 9 minus r, and here we have 3x into 3y, which is 9 by 4, which is bigger than equal to 1. If you solve this further, okay, we are going to get somewhere 4r plus 4 bigger than equal to 81 minus 9r. So we are getting r bigger than equal to 77 by 13. So this is 5 point something. So R is 6. So we have only one greatest numerical term, which is seventh term. T save 6 plus 1 is the greatest term. Okay, got it. Let's move ahead. So 10 to the power n 3 into 4 to the power n plus 2 plus 5. N belongs to n. The greatest value of the integer which divides fn. The greatest value of integer which divides fn. Okay, so let's make something fn. Can we write this as 9 plus 1 to the power 9? We have 3. Can we write this as 3 plus 1 to the power n plus 2? Can we write it 6 or 5? Let's keep it 5. 5 only, okay? Now expansion of this is what? 9c0, 9 to the power 0, nc1, 9 to the power 1, dot dot dot. Here we have 3, n plus 2 c0, 3 to the power 0, n plus 2 c1, 3 to the power 1, dot dot dot, and we have 5. So if you see, this term is 1 and this is multiple of 9 lambda. This term is 1 and this term is 9 lambda, and this is 5. If you see, it is 9 lambda and this is 9. So this is 9 big lambda. So 9 is the bigger divisible. 1000 to the power n upon n factorial. Then the greatest value of n. Okay. So what can we do is that if we put an equal to 2 to the power n and 500 to the power n, and this is n factorial. Okay, an is greatest when so this is somewhere an identity type of thing. Okay, so we'll go through options. Okay, we are going through options. It is 1000, 1000, 1000, and we are left 1000. uh, we multiplied this, we went through sometime, and dot dot dot, we are left with 1000 to the power 997, and this is 997 factorial. Okay, and in one case we took 1000 n minus 998, and we have 1998, and we have 998 factorial. Okay, so simply what we are trying to say is that this is the list one. Yes, this is the list one. 1000 n minus 997, 1000 997 upon 997 factorial. Okay. So in while we were doing 998 factorial, one number was getting multiplied with 1000, and now it is getting, in place of 1000, it is getting multiplied with 1000 upon 998. Okay. I mean to say that if this is x, if this is x, now what happened? We divided x by 1000 and multiplied with 998. Then we got somewhere the new term y. Normally we have to get that, we get some middle term. Okay. So we'll do this. This identity is not known by us right now. We'll do this. Okay. We'll come back. Let's move ahead. So in the expansion of this, the sum of binomial coefficient is 256, and four of the terms with the greatest binomial coefficient exceed. Sum of the binomial coefficient is 256. So what will happen? We'll put x equal to 1. We are going to get 3 to the power minus 1 by 4, and here we are going to get 3 to the power 5 by 4. This is equal to 256. So we'll do simply 1, 3, 3 by 2 to the power n, and c0 equal to, no, we don't do anything. Okay, this is 2 to the power 2 to the power 8. Sum of the binomial coefficient. So we go with this thing. Okay, wait. In the expansion of 3 to the power minus x by 4, 5, 3 to, uh-huh. So the expansion is nc0, 3 to the power minus x by 4, n minus 0, 3 to the power 5x plus 4. Okay. 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 I could understand that what they are trying to say. If we pull 3 to the power minus x by 4 out, 3 to the power of n by 4x, we get 1 plus 3 to the power 3 to the power 3x by 2 to the power n. So its expansion is somewhere 3n x by 4 nc0 nc1 3 to the power 3x by 2 nc2 3 to the power 3x nc3 x to the power 3 into 3x by 2 dot dot dot. Though we have to know the coefficient, which is equal to 2 to the power 8 So what will happen? We'll give this question as a homework and we'll come back to this. Okay, we'll give this question as a homework and come back to this. This question you can solve on your one remainder and last term. Okay, so from here you get at least one question in the exam. Okay, here you get at least one question in exam. Okay, so I'm trying to find the question based on the numerically greatest remainder. Okay, so in remainder what will happen? If some number is given, we have to find what is the remainder of that. Okay, okay, we don't have wait a second. So in remainder what will happen? We will have some question like if we have 7 to the power n plus 5, then uh, then what is the remainder? What is the remainder when it gets divisible by 6? What is the remainder? So what will happen in such type of question? We'll write 7 as 6 plus 1 to the power n plus 5, and we'll expand this as nc0 6 to the power 0 nc1 6 to the power 1. Now whatever term will come, it will be nc2 6 square. So whatever term will come, that will be multiple of 6, and we have 5. So 5 and this is 1. Can we say that this is 6 and anything coming is 6 lambda? So can we say that this is the multiple of 6 alpha? So remainder is 0. So this type of question meaning that what is the remainder? Okay. And similarly we have like what will be the last term? So when we expand this, what is the last term of this expansion? So we will be having something. Okay, we'll go through such examples. So this question we already solved right now. This question. What is the remainder when 7 to the power 81 is divided by 5? Now we have 7 to the power 81. We have to make it in the form of 5 lambda or something. So if you see, it is 7 into 7 to the power 80. If you see, it is 7 into 49 to the power 40, and it is 7 into 50 minus 1 to the power 40. Now we'll do expansion of this one. So which is 7 already there, and we are doing expansion, which is okay. Yes. Okay, yes. So it is 40 C0, 50 to the power 0 minus 1 to the power 40, which is 1, minus 40 C1, 50 to the power 1, okay, plus 40 C2, 50 to the power 2. It will keep on going. Now if you see, this is 7, this is 1, this is 50, 50, 50. You know that 7 to the power 81 is a positive term. This is positive. That means anything this should also be positive. This is single one, and 7 to the power 81 is very big term, so that means this is also positive, and this is the multiple of 50. Can we say it is 50 lambda? Similarly, can we say it's 7 plus 350 lambda? Now when we divide by 50, this is divisible by 50, and when we divide this by 5, the remainder is 2. Okay, and one more thing, if you try to see the digit last digit of this number 7 to the power 81, for example, you see that lambda is some number, so some number with 0, so the last digit of 350 lambda is 0, and we are adding 7, which is 7. Got it? This is the way this is the way we find the last digit. Okay, for last two digit we have some different criteria, so let's move ahead. Last digit of this number. Okay, so last digit we can simply say that 3 is at the end, so 3 threes are 9, 3 threes are 9, 9 threes are 27, 27 threes are 1. So after 13 to the power 4, we are getting last digit at 1, and now 1 to the power 3 whole cube is 1. Last digit is 1. By our class 19th experience, we can say this thing. Okay, but so this is the only way we can do. Okay, so 1 is the last digit. So which is the larger number? Which is the larger number? So what will happen? We can write 1.1 to the power 1 lakh as 1 plus zero point 0.1 to the power 1 lakh. So if we expand it, can we say 1 lakh C0 0.1 to the power 0, 1 lakh C1 0.1 plus dot 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 dot. So if you see, this is 1, this is 10 lakh into 0.1, which is 10,000 plus zero point 0.1. So if you see, it is 10,000, it is bigger than 10,000. That's the answer. So n is a positive integer, then show that 6 to the power n is divisible by 5. Okay. So we have to show that this is divisible by 5. So 6n minus 5n minus 1. Can we write it as 5 plus 1 to the power n minus 5n minus 1, which is nc0, 5 to the power 0, nc1, 5 to the power 1, nc2, 5 square. Now whatever term will come, it will be 5 cube or whatever. It will be somewhere like 25 lambda. And we have 5n minus 1. If you see, this is 1, this is 5n, and this is overall 25 alpha. Alpha is some integer. 5n minus 1. This cancel. So we are left with 25 alpha. Hence divisible by 25. Okay. Remainder when 3 to the power 257 is divisible by 80. So what will happen? 3 to the power 57. We have to somehow try to create 81. So the 81 is 3 to the power 4. So if we make it 256, okay, 3 into 3 to the power 256, we can simply write is 3 into 3 to the power 4, 64. We can simply write it as 80 plus 1 to the power 64. If you solve it, it is 64 C0, 80 to the power 0, 64 C1, 80 to the power 1, and whatever term will come, that is the multiple of 80. So it is somewhere 3 plus 3 into 80 into lambda. So the answer is 3. First, the last digit, the last two digit, the last three digit of this number. Okay. So what will happen? We'll try to form this number in the form of 10. So 81 to the power 25 is 3 to the power 4 to the power 25. It is 9 to the power 50, which is 10 minus 1 to the power 50. So if we expand this, it is 50 C0, 10 to the power 1, 10 to the power 0, minus 50 C1, 10 to the power 1, plus 50 C2, 10 square, okay, plus 50 C3, 10 cube. That means here we are getting 3 zeros. Now here onwards we will start getting 3 zeros. Yes. So it is 1, this is 500, this is 50 into 49 into 50. Okay. If you solve it, and this is 1000 lambda. So first digit, second digit, third digit. So on solving this, 50 common. Okay, 1 is here, minus 50 common. So it's a 10 minus 49, which is minus 39. Okay, sorry. It is 1 minus 500. This is 500 into 49 into 5 plus 1000 lambda. So 1, 500 common. We are getting 1 minus no 9 5 the 45. This is it. Okay, this is 1000 lambda. And if you see, this is 1 minus minus plus 500 into 244. This is 1000 lambda. So this is 1 and this is 1000 into 122. Okay, it is still okay, it is still coming out to be 1000 lambda. So we are getting 1000 lambda plus 1. So last digit is 1 0 0. Last three digits. Okay, this is it. Okay, which number is greatest? So which number is greatest? Okay, so what will happen? We'll do 1 plus zero point 0.3, 2000. Okay, 2000 C0, 2000 C1 0.3 to the power 1. So this is 600 and this is 1 and this is some value. So overall this is bigger than 600. So the way we solved the previous one. Yes. Now I think we can solve 1 2 3 based on our previous things. Yes. Now this one, which is bigger? So 99 to the power 50 could be written as 100 minus 1 to the power 50, which is 50 C0, minus 50 C1. Okay, so we are doing 1 minus 50 to the power 100. Okay, into 100 plus 50 C2 100 square minus dot dot dot. And what will happen if you see, this is it. If you go with 101 to the power 50, this is 100 plus 1 to the power 50, which is 50 C0, 50 C1 100, 50 C2 100 square plus dot dot dot. Okay, so what will happen? What will happen? We have to get this thing, isn't it? Last term is 50 C50 100 to the power 50. Okay, so we have to show this. In 105 to the power 50 minus 99 to the power 50, we are going to get 2 to the power 2 into 50 C1 100 50 C3 100 to the power 3 plus dot dot dot. Okay, okay. So this is what we are going to get. We have to show that which is bigger. Okay, 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 okay. No. From this, if we minus this, we are getting some positive term. In this, we'll get the last term to be 50C, 49, 100C, 100 to the power 49. Okay. So what will happen? We are getting somewhere 50, 100 to the power 49 into 2 plus 2 sum term. This is what? 100, 10, this is 100. 100 to the power 50 plus 2 into sum term. So the difference is bigger than this thing. That means the difference of this and this and this is bigger than this thing. That means 101 to the power 50, 100 to the power 150 is equal to 99 to the power 50 plus 100 to the power 50 plus 2 into some terms. That means 100 to the power 1, this is bigger than 99 to the power 50 plus 100 to the power 50. So that means this is bigger. Simply get it. Remainder of this. So what will happen? We'll try to form it at 2 cube, and this is 16 to the power 500. We'll write 8, 17 minus 1 to the power 500. We'll write 8, 500 C0. We'll write 1 minus 17. Okay. It will come out with this 500 C1 17 plus dot dot dot. We are getting 8 minus 8 into 7 lambda, 17 lambda. So 8 is the remainder. Last two digit. We'll try to form 9. Last three digits. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is 10 factorial. We have to find last three digits. So what will happen? First we'll try to find 10 factorial could be in the power of 2 to the power a, 3 to the power b, 5 to the power c, 7 to the power d. So what will happen if we get a 3 and c3? Then we can simply say it. Okay. So 10 by 2, 10 by 2 square, 10 by 2 cube. This is the greatest integer way. So 2 5s are 4 2s are 8 1s are. So it is 7. So we are getting 2 to the power 7. And we have 10 by 5, which is 2. So it is 5 square. Okay. Okay. Other terms are 7. So we'll go with 10, 3. 10, 3 square, which is 3 plus 1, 4. Now we'll go with 10, 7. 10, 7 square is 0. So it is 1. So this is 3 to the power 4, 7 to the power 1. So if you see, we are going to get 25 into 400, and we are left with 2 to the power 5, 3 to the power 4 into 7. So last digit coming out from this is what? 2 threes are, 2 fives are. This is 2, this is 1, this is 7. So 14. So 400 is last three digits. 400 is last digit. Now we can solve this one. We can solve this one as well. We are on lecture third. Okay. This is the important lecture of binomial theorem. Okay. This is the important lecture of binomial theorem. We'll give it a good time. Okay. Before that, I am giving you 1 or 2 minutes of break for drinking water and everything, such that we can come with the full form. Okay. So let's take it. Okay. Yes. Yes. Yes, sir. I understand. Very well, sir. Yes, sir. Okay, sir. Yes, sir. Hello. Hello, sir. Okay, sir. I will come. So paper is when, exam is when. Okay, exam completed. Half an hour, yes, sir. Hello, sir. Sir, your voice is breaking. Hello. Hello. Yes, sir. Your voice is breaking. Hello, sir. Hello, sir. Yes, sir. Okay, sir. I am coming. Sir, student will be there only, sir. So now we are on the properties of binomial coefficient. We'll study this very nicely because it has very much weightage. Okay. So we'll continue. We'll start with the basic property. Okay. If it is NCR, we can say it NC N minus R. Okay. Okay. Or you can say that if it is NCX and this is NCY, we can say X equal to Y or X plus Y equal to N. Second, NCR plus NCR minus 1 will be N plus 1 CR plus 1. Okay. N plus, this will be R only. Okay. N plus 1 CR. Okay. Third, NCR is N by R N minus 1 C R minus 1. My question is, if you could not remember this thing, you can simply make it n factorial upon r factorial into n minus r factorial plus n factorial upon r minus 1 factorial into n minus r plus 1 factorial, and you can take LCM and you will finally get this thing, isn't it? So similar this one, you will get this thing. Okay. Fourth one, NCR upon NC R minus 1 is equal to N minus R plus 1 upon R. Okay. Simply expand it, you will get it. Okay. Okay. Now we have second. We have sum of coefficient. Okay. Sum of coefficient. So if you remember, we have to find something like, if you remember, it is 1 plus x to the power n. Can we write this as nc0 nc1 x nc2 x square nc3 x cube plus dot 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 ncn x to the power n. Now put x equal to 1. Can we say that 2 to the power n is equal to nc0 could be written as c0, c1, c2 dot 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 Cn. So we got one formula from here. Now second, if we put x equal to minus 1, can we say that 0 is equal to c naught minus c1 plus c2 minus c3 plus dot minus 1 to the power n cn? So this is the second formula we have got. Okay, okay. Now what will happen? What will happen is that we have to find sum of coefficient of even and odd powers. I think powers, isn't it? Odd powers. So even power. If we go with even power, it is C0, C2, C4, C6. We have to get C, maybe N or whatever. We don't know. So M belongs to even and it is last. Okay. So we have to find this sum. So we have to find the trick for this. So what will happen if you see this equation 1 and if you see this equation 2? Okay. So if you do 1 plus 2, we are going to get somewhere 2 to the power n plus 0. And this is 2 times of C naught, C2, C4, Cm. And from here we can get 2 to the power n minus 1 equal to C naught, C1, C naught, C2, C4 dot. Now if you remember, from second, from second, if we take out C1, C2, C1, C3 minus sign numbers on the next side, can we say that C1, C3, C5 plus dot is equal to C naught plus C2 plus C4 plus dot is equal to 2 to the power n minus 1? Okay. So this is properties we have to do by proof. Okay, let's move ahead. Sum of the coefficient with the alternate sign, we did it. Sum of the product of coefficient. So what will happen if we have to find sum of the coefficient, sum of the product of coefficient, sum of the products of the coefficient. So what will happen if we say 1 plus x to the power n, 1 plus x to the power n. If you expand it, what are we going to get? nc0, nc1, nc2, dot dot dot, ncn, x to the power n. We are going to get nc0, nc1, ncn. Okay. Now if you see, the products are going to be somewhere nc0, 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 nc1, and this is going to be complete product. Yes. Can we say that? Can we say that every product? Okay, what will happen? nc0, nc0 will come this way. Okay. 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 So this is the product. Okay. We can simply say that the answer of this could be, when we put x equal to 1, it is 2 to the power 2n, isn't it? Now if we take one example, we have 1 plus x to the power n. Okay, this is what we have. We have to find the sum of c0, cr, c1, cr plus 1, c2, cr plus 2, plus dot dot dot, cn, c0. Isn't it? We have to find the sum of this coefficient. If you see, this could be written as c0, cn minus r. This could be written as c1, cn minus r minus 1, c2, cn minus r minus 2. Similarly, if you see, it is the last number is cn minus r. Okay. So it is cn minus r, and this is n. Okay. And this is cr. Okay. If you see, the sum of this is what? N minus r. The sum of this is what? N minus r. The sum of this is what? N minus r. The sum of this is what? This is n, so this will become 0. So n minus r. So if we fill that 1 plus x to the power n, 1 plus x to the power n, if it is expanded, if it is expanded, if it is expanded, these are what? These are giving x to the power 0, x to the power n minus 1. So from here we are getting x to the power n minus r, and these terms, yes. So can we say that can we say that from 1 plus x to the power 2n, we wanted to have some coefficient in which x has power n minus r. So can we say 2n c n minus r x to the power n minus r is the same thing? So can we say that the value of this digit, this number is nothing but 2n c n minus r? So this is what I am trying to see. Okay. So this is what I was trying to say. Now we came to this question. Okay. In this question we are told that for r equal to 0 to 1 up to 10, let AR, BR, CR denote respectively the coefficient of x to the power r in the expansion. So the coefficient of x to the power in the expansion r. So AR is 10 CR, BR is 20 CR, CR is 30 CR. Okay. Now when we are going with summation, AR is what? 10 CR, B10 is what? B10 is 20 C10, BR is what? 20 CR, and minus summation of R equal to 1 to 10. R equal to 1 to 10. AR is 10 CR, C10 is 30 C10, AR is again 10 CR. Okay. So what will happen? It can go only up to 10. If you find here 20 C10 is out and we have 10 C 10 minus R 20 CR, R equal to 1 to 10, and here we have 30 C10 out, we have summation R equal to 1 to 10, 10 C 10 minus R 10 CR. Okay. So if you keep it like this 20 C10 and once try to see that in 1 plus x to the power 10 and from 1 plus x to the power 20. So from this thing which is coming, which is from 1 plus x to the power 10 and 1 plus x to the power 20. This is the things in which one of the term will be 10c0. So when r is 10, it is 0. So it will start from 10c9, 20c1 to 10c8. It will go like this. Okay. 10c8, 20c2 dot 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 10c0, 10c0, 20c10. So you find that it is starting from 0 to 9. We are not going to 10c10, 20c10. So for that reason we will add 10c10, 20c10 minus 10c10, 20c10. Okay. So can we say that from this, these all terms are coming out to be 30c10. So it is simply 20c10 dot 30c10 and minus 20c10, 20c10. Okay. And from the other part, which is minus 30c10, if you find it is going from It is going from 10C1, 10C9 to 10C10, 10C0. So we are left with only one term, which is 10C0, 10C10. So we'll minus 10C0, 10C10. Okay. So finally we are from here we are getting minus 30C10, and this is 20C10 plus 30C10, 10C10. Okay. So this and this getting cancelled. So we are overall going with 30C10 minus 20C10, 20C10. Okay. So let's solve it further. Uh, so what will happen in this also we'll solve it. Okay. Wait. So in 1 plus x to the power 20, we are trying to find the power of. So this is 10C10, yes. So this is x to the power 10, and we are trying to get 10 out of 30. So can we say that it is 40C20, and this is 1 plus x to the power 20, 1 plus x to the power 20. So can we say it is 40C20, which is 0. Okay. Now this question, this is simply from property. We have r equal to 1 to 10. So if you don't remember it, we will have to just open it. N factorial, r factorial, n minus r factorial, n factorial, r minus 1 factorial, n minus r plus 1 factorial. So it is nothing but summation r equal to 1 to 10, n factorial cancel, r minus 1 r cancel, this cancel to this one, and this r going cancel to this one. So we are simply left with n plus 1 minus summation r equal to 1 to 10, which is nothing but 10 plus 1 by 2, and this is nothing but 10 into n plus 1. If you solve it, it is 10n plus 10 minus 55, which is 10n minus 45. Okay. Now this is the question. NCR n minus r. Okay. So what will happen? We'll take RCR, and the next one is r plus 1 CR. If you find it, it will come out to be r factorial, 0 factorial, and this is r plus 1 factorial, r factorial 1 factorial. Okay. So what will happen if you take r factorial common? So r factorial, we are going to have 1 plus r plus 1, which is nothing but r plus 2 c r plus 1. So what is happening? This got increased, this got increased. Now we have next term. When we got this thing, we have next term something like r plus 2 cr, and we are here r plus 2 cr plus 1. So we are going to get r plus 2 r plus 3 cr plus 1, and again we have r plus 3 cr to get added with r plus 3 cr plus 1. So we are going to get r plus 4 cr plus 1. So similarly what will happen, we will reach up to here. So at r plus 4 we'll get r plus 4, r plus 5, r plus 1. So now we are available with ncr, and at the end we will be having ncr plus 1. So this is n plus 1 cr plus 1. So we got the proof. Now based on the last proof we have this question 47 c4 plus, now we have 51 c3, 50 c3 dot 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 47 c3. So we got that 47 c3 plus 47 c4 will give us something 48 c4, and we are left with 48 c3, and then we have something 49 c3, 50 c3, 51 c3. So from last formula we know that their summation will come out to be 52 c4. Okay, now in this question we have summation r equal to 0 n minus 1. We have ncr. So we know that ncr plus 1 will come out to be n plus 1 cr plus 1. Yes, and further solving, this is n factorial r factorial n minus r factorial upon n plus 1 factorial upon r plus 1 factorial n minus r factorial. So if you see, this get cancelled with this one, n will get cancelled this one, this will make this cancelled. So we are somewhere getting summation r equal to 0 to n minus 1, and we are going with r plus 1 upon n plus 1. So we are varying with only r, so we'll simply make it like 1 upon n plus 1 common summation r equal to 0 to n minus 1. So this is r plus 1. So we are summing from 0. So at 0 we'll have to check at 0. Okay, so at 0 it is 1, at 1 it is 2, up to n. At n minus 1 this is n. So can we say this is n plus 1 by 2, and we have n plus 1, so we are simply getting n by 2. So this is the answer. This is very good question. JEE Advanced previous year question. We are given an equal to summation of r equal to 0 to n 1 upon ncr. Now we have to find this value. So this value could be written as n upon 1 upon ncr and minus 2 times of r ncr r equal to 0 to n. So we can say simply that this is n an. Okay, r is 0 to n. This we can write this thing minus 2 times of. For this we'll have to make some trick. Okay, now you see when r is 0, this is 0 upon nc0. When it is 1, it is 1 upon nc1. When it is 2, it is 2 times of nc2, which is 1 nc2 1 nc2. When it is 3, it is 1 nc3 1 nc3 1 nc3. Yes. When it is 4, it will come 4 times. When it is 5, it will come by 5. When it is n, it will come n times, isn't it? Now what will happen? What will happen is that there will be a term n by 2 in the middle, 1 by nc n by 2. So before that we have 1 upon nc n by 2 minus 1, and here 1 by nc n by 2 plus 1. So what will happen? If you add this term and this term, you will find that this is getting, what I am trying to say, that this will fill this option. So from beginning we have c0 c1 c1 c1. Okay, it is 0 0 by c1 1 by c1. So it is 1 by c2 1 by c2 1 by c3 1 by c3 1 by c3. So it is 1 by c4 1 by c4 4 times. So similarly this is going 1 by cn n times. Okay, this is n times. Okay, now what will happen? For 1 by ncn, we are subtracting minus 0 by nc0. For 1 by ncn minus 1, we are adding 1 upon ncn minus 1 and subtracting 1 upon nc1. That means this is getting cancelled, this is getting cancelled. Similarly we'll move here, we will be having 1 upon nc n by 2. Before that we will be having 1 upon, before this we will be having 1 upon nc n by 2 plus 1. Yes, and before this one we will be having 1 upon nc n by 2 minus 1. So what will happen? This gap will be filled by, if we put this gap in this, we are going to have somewhere n ncn plus n ncn minus 1 dot 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 n nc n by 2 plus 1. Okay, plus n by 2 nc n by 2. So this is what we are left with. So what will happen? So what will happen if you see this result? This result is nothing but We'll add n by 2 to this one. Okay, we'll add n by 2. We'll add n by 2 cn by 2, and we'll minus n by 2 and cn by 2. Okay, so if you see, it is nothing but n an, and the last one nc n by 2, which is left as n by 2. So this is nothing but n to n, and this is 0. Okay, do we have a space? No, we don't have a space. So I wanted to show you once again. Okay, this is a good question. So what I'm trying to say is that this answer is coming out to be 0. Okay, this answer is coming out to be 0. This is what I'm trying to say. Wait, I'm saying that if we are getting 0 c0, 1 c1, 1 c2, 1 c2, similarly it is 3. One time we'll get 1 c n by 2 minus 1 up to 1 by n c n by 2 minus 1, and here we'll get up to 1. This is n by 2 minus 1 time, this is n by 2 times, so we'll get 1 upon n c n by 2, and at one of the a's we'll get 1 upon n c n by 2 plus 1, and now we are going more up to 1 upon n c n. Now what will happen? In order to make this n times, we have to add 0. 0 times c0. So we added 0 upon c0 and subtracted minus 0 c0. In this one, we added 1 upon c1 and we subtracted minus 1 upon c1. In the last one, we have to add 2c2 and subtract. So what is happening by doing this? If we reach up to minus n by 2 minus 1 n by 2 nc n by 2 minus 1. Okay, so if we do such things, we are going to get somewhere n by 2 1 by c0 1 by c1 dot dot 1 by cn. This is what I'm trying to say. Okay, so you see that it is n by 2 an. Now we got n by 2 an, so we are multiplied with 2. Okay, so from ncr, so this is what n an, and this is n by 2 an, which is nothing but n an, which is equal to 0. This is what I am trying to say you. Okay, so in this question, this is a JEE mains question. So S1 is summation j equal to 1 to 10. We have j minus 1. We have 10 factorial, 10 minus j factorial into j factorial. Okay. If you go further, it is summation j equal to 1 to 10. This is 10 factorial. This is 10 minus j factorial. And this is j minus 2 factorial. So what will happen if we do minus 2 plus 2 in this number? It will come out to be somewhere summation j equal to 1 to 10, 10 into 9 into 8 factorial upon 8 minus j minus 2 factorial into j minus 2 factorial. So if you see, it is nothing but 90 into summation j equal to 1. Now it's a j equal to 2 to 10. At 1 it is going to be exact 0. At 2 it is going to be 2 into 1. Okay. So j equal to 2, this is nothing but 8c j minus 2. Okay. Similarly, if you see for S2, it will come out to be 10 summation j equal to 1 to 10, 9c j minus 1. Okay. Okay. Similarly, S3 will come out to be similarly S3 will come out to 10 summation of j equal to 1 to 10, 9c j minus 1. And here we have j already, one more j. So we'll do minus 1 plus 1. So when we do plus 1, we have 10 j equal to 1 to 10, 9c j minus 1, and we'll have 90 summation j equal to 2 to 10, 8c j minus 2. So you can see that S3 is somewhere S2 plus S1. S3 is equal to S2 plus S1. But S1 is coming something different. S1 plus S2 is not 50, 49, 45 plus 5. 50 it is coming. So we have to check the value of S3. So S3 value we have to check first. So 9, it is 10 into 2 to the power 9. it is 9, yes. So it will not go up to 10. It will go from 1 to 9 only, okay? So it will go from 1 to 9 only. No, at 10 it will be 9. 1 to 10, okay? It is 1 to 10, 1 to 10 only, okay? So at 1 it is 0, at 10 it is 9. So it's a 2 to the power 9 plus 92 to the power 8. So I think 92 to the power S1 is correct, S2 is wrong, okay? So this question, solve it as a homework. This question, you can solve it as a homework or I am helping you to solve it. 39C 3R minus 1 plus 39C 3R is equal to 39C R square minus 1 plus 39C R square. So this is simply 40C 3R and this is 40C R square. So we can say that R square plus 3R is equal to 40 or R square is equal to 3R. That means R is 0 or R is 3. And from here we'll get R square plus 3R minus 40 equal to 0. If you solve it, R equal to minus 3 plus minus root under B square minus 4AC upon 2A, which is nothing but minus 3 plus minus 13 by 2, which is 5 and minus 8. R is not negative, so we have three values 0, 3, 5. Now in this question, what will happen? So we have NCR and NCR plus 1, and we have 3 times of NCR plus 1 and NCR plus 2 plus 3 times of NCR plus 1 plus NC, this is RC2, okay, NCR plus 3, and we have NCR plus 4. One NCR plus 3 will come to NCR plus 4, and at the bottom we have NCR plus NCR plus 1 plus 2 times of NCR plus 1 plus NCR plus 2 plus NCR plus 2 plus NCR plus 3. Okay. Now this is what? N plus 1 C R plus 1. This is what? 3 times of N plus 1 C R plus 2. This is what? 3 times of N plus 1 C R plus 3. This is what? N plus 1 C R plus 4. And at the bottom what will happen? We'll have N plus 1 C R plus 1, 2 times of N plus 1 C R plus 2 plus N plus 1 C R plus 3. We'll again what do? We'll give 1 to this, 1 to this. So we'll get N plus 2 C R plus 2, 2 times of N plus 2 C R plus 3 plus n plus 2 c r plus 4. Okay, and now in the bottom we are going to get n plus 2 c r plus 2 plus n plus 2 c r plus 3. If you go further, now bottom will come out to be simply n plus 3 c r plus 3. It will come out to be n plus 3 c r plus 3, and it will come out to be n plus 3 c r plus 4. And finally you are going to get n plus 4 c r plus 4, n plus 3 c r plus 3, and which is going to be further n plus 4 factorial. We'll have to solve it. Okay, we are solving this one. Okay, n plus 4 factorial upon r plus 4 factorial n minus r factorial n plus 3 factorial n minus r factorial r plus 3 factorial. So r plus 3 gone, n minus r gone, n plus 3 gone. We are simply getting n plus 4 r plus 4. So k equal to what? K equal to 4. Okay, this was good question, that was good question, and this question I would like you all to get it as a homework. Okay, I would like you all to get this as a homework, or you want me to solve it? Is simple, you can solve it. This is, try this as a homework. 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 Okay, sum of the coefficient. Sum of the coefficient. So we are given that 1 plus x to the power n, which is c0, c1x, c2x square, c3x cube plus dot 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 cn x to the power n. Now sum of the coefficient is, put x equal to 1. We are going to get 2 to the power n equal to c naught, c1, c2, cn. So now move to this question. Moving to this question, we have to find 4 c naught 4 square c2. Okay, so if you see, you put x equal to 4 in this equation, we are going to get 5 to the power n equal to c naught 4 c1 4 square c2 cn 4 to the power n. In second, we have 3 c naught 5 c naught. Okay, so first we will write general term, tr term. So we have 2r plus 3 CR. This is the general term. Okay. So we'll write this as 2 n n minus 1 C R minus 1, and this is 3 CR. So C naught C1, this we have to find the summation of TR, where R is from 0 to n. Yes. So when this is R minus 1, we'll convert this as R equal to 1 to n, and we have 2n, n minus 1 C R minus 1, and here we have summation R equal to 0 to n CR. So it is nothing but 2n. This is 2 to the power n minus 1. This is 3. This is 2 to the power n. So if you see it, it is nothing but 2 to the power n plus 3. Okay. Third. Third is this thing. Third, I think we have some space. Okay. So we are moving to some space. Otherwise, what can happen? If we integrate 1 plus x to the power n from 0 to 1, okay, so we are going to get 1 plus x to the power n plus 1 upon n plus 1. This is from 0 to 1. At 1 we have 2 to the power n plus 1. This is it. And this is what? This is LHS. When we go to RHS, integration 0 to 1, C naught dx, C1x dx, C2 x square dx, it will go up to 0 to 1, Cn x to the power n dx. We will find that it is nothing but C naught x 0 to 1, C1 x square by 2, 0 to 1, C2 x cube by 3, 0 to 1. If you keep on going dot dot dot, you are getting Cn x to the power n plus 1 upon n plus 1, 0 to 1. At 0, all are 0. At 1, it is C naught, C1 by 2, C2 by 3, dot dot dot, Cn by n plus 1. So our RHS is equal to LHS, and we got this answer. So this is the way we have to try to use some trick. Okay. So now we are here. K equal to 1, 2, 3n. So if k is 1, what is going to happen? Just we will first visualize. C1 minus 3. K equal to 2. C 3 minus 3 to the power 2. Okay. Okay. So it will keep on going 6n c 6n minus 1 minus 3 to the power 3n. Okay, so this is what it is going to happen. Let's write it more simplified manner. Okay, 6n c1 6n c3 3 square, this is minus 3 cube, and this is 6n c5 plus dot 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 6n c 6n minus 1 minus 3 to the power 3n. So what to do in this? Power is coming even and that is coming odd. Power is even. Okay, what can we do is that we have 1 plus x to the power 6n minus 1 minus x to the power 6n. If you see, the expansion of this is what? 6n c0 x to the power 0, 6n c1 x to the power 1. Similarly, it will go up to 6n cn 6n 6cn, okay, x to the power 6n. If you do minus, we are going to have 6n c0 x to the power 0, 6n c1 x to the power 1, dot dot dot. So if you see that, if you minus, the even terms are going to get minus and we are going to get 6n c1 x 6n c3 c3 x cube plus dot dot dot. Okay, got it. So now we are putting what? We are putting uh, so what we should be getting is that this should come 6 and c3 should come out to be 3 square 1 2. So we are getting 2n minus 1, 2n minus 1, yes. So our general term is coming out to be 2 6n c 2k minus 1, and this is x to the power 2k minus 1. We have to bring this as x to the power 2k minus 1, yes. So what will happen? So what will happen is that Uh, if we try to take 1x that side, so k is varying, isn't it? K is varying. So what will happen? We'll do 1 plus x to the power 6n minus 1 minus x to the power 6n by x. Okay, it is still x squared. So 1 at 1 it is 2, 4, 6. So now if we divide 1, we divided by 1xk and we will take this to this side, dividing to both the sides. Okay. So now what are we happening is that we are getting this thing, and when we put k equal to 1, we are going to get 6n c1 x square 6n c3 x4 dot dot dot, and here we have 1 plus x to the power 6 minus 1 plus x to the power 6n 1 minus x to the power 6n upon 2x. Now if we divide by x square both the sides, I think we are going to get some result similar to that or not. We will divide by x square both the sides. Uh, are we still going to get or not? Wait, if we divide by x square, we are getting x 1. We will divide by x only. So we'll get x cube again. Can we put x equal to root x? We'll put x equal to root x. So we are going to get 1 upon root x 6n upon, we have not divided. This is 2 root x minus 1 minus root x to the power 6n. It is 6n c1 x 6n c3 x square. Okay, now everything is going fine. Okay, so what will happen now? We have to put x equal to minus 3. So we'll get somewhere 1 plus root 3 iota to the power 6n minus 1 minus root 3 iota to the power 6n upon 2 root 3 iota. This is our summation result. Yes, now we have to solve this thing, isn't it? So if you have space next, we don't have space here. So this could be done by, we'll divide by 2, multiply by 2. So 2 to the power 6n, it is e to the power iota pi by 3, 60 degree, yes, into 6n minus e to the power iota, sign is negative, minus pi by 3, okay, minus pi by 3 into 6n upon 2 root 3 iota. It is nothing but 2 to the power 6n, 2 to the power 2 into root 3 iota, and this is 2 pi. So cos 2 pi is 1, and this is sin 2 pi. uh, it is again minus iota 2 pi. So sine cos 2 cos minus 2 pi is 1, sine 2 pi is 0. So the answer is 0. So this answer is 0. So this is the question. So if you see, it is 50 C0 and this is 50 C 50 minus R. It is 50 minus 1, okay? It is 50 C1. This is 50 C 50 minus R minus 2. Or you can simply say that it is R equal to 1, R equal to 2. So it is 50 CR only, okay? It is dot 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 50 C 49 and it is 50 C 50 minus R. So when R is 50. So this is somewhere, if you see, this is coming out to be 1 plus x to the power 50, 1 plus x to the power 50 and the coefficient when R is 1, this is 49 and this is 0. So and when R is 1, this is 1. When R is 2, this is 1, this is 48. So we are getting the coefficient of 49 from 1 plus x to the power 100. So this is the answer. Got it? This is what it is trying to say. Now we are coming to this one. 1 plus x to the power n is equal to c naught c1x c2x square cn. Okay. Now we have to find this. So if we see, it is nc0 nc n minus 1. This is nc1. This is nc n minus 2. nc2 nc n minus 3 plus dot 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 nc n minus 1 nc0. So if you see that 0 and n minus 1, it is coming out to be n minus 1. This is coming out to be n minus 1. This is coming out to be n minus 1. This is coming out to be n minus 1. So we can say that if it is 1 plus x to the power n and it is 1 plus x to the power n, it is something 1 plus x to the power 2n, and out of that we are trying to find the coefficient of n minus 1. This is it. Or 2n c n plus 1. So this is what it is trying to say. Now we are expert in properties of coefficient. Now we have second question, 1 square. So if you find the general term, it is nothing but r square ncr ncr. By the property we know that it is nothing but n square n minus 1 cr minus 1 n minus 1 cr minus 1. And if you see, it is nothing but n square n minus 1 c n minus r, and this is n minus 1 c r minus 1. So we have to find summation of n square is common because r is varying. R is varying from 1 to n. So it is n minus 1 c n minus r, and this is n minus 1 c r minus 1. Can we say that from 1 plus x to the power n minus 1, 1 plus x to the power n minus 1, we are getting the coefficient of n minus 1, which is 2n minus 2 c n minus 1, and we have n square there. So this is what our final result is. Now we are coming to this question. Okay, this is very good question. Okay, this is very good question. Advanced level, IIT advanced. So what will happen? 4c4 3c3. If we consider that 1 plus x to the power 101 minus 1 to the power 4, the expansion is what? 4c0 minus 1 to the power 0, 1 plus x to the power 404 minus 4c1 minus 1 to the power 1. So we already took minus, okay? 1 plus x to the power 303 plus 4c2 1 plus x to the power 202 plus, now it's plus minus, 4c3 1 plus x to the power 101, and we have 4c4 where we have 1 plus x to the power. What will happen? This is coming one whole 4, 104 to the power 4, 101 to the power 3, 101 to the power 2, 101 to the power 1, 101 to the power 0. Okay, so we are told that this is 101 to the power k. So now what will happen? This is it, okay? No, we have told that out of this, if someone will come out to be. So 4c0, 404 c4. Okay, we got x to the power 4, x to the power 400, x to the power 4. Okay, now from here we are getting 4c1 303 c4. That means it is x to the power 4. Similarly, 4c2 202 c4, 4c3 101 c4, and 4c4 1 to the power 1 plus x to the power 0. So from here we are not going to get any coefficient of x to the power 4. Okay, so this is it. They are all x to the power 4, x to the power 4. Yes, so what can we do is that, can we say that on this expansion we are getting x to the power 4. So from this expansion if we get x to the power 4, that means 101 c0, 101 c1x, 101 c2 x square plus dot dot dot. We have minus 1 whole power 4. 1 will get cancelled. Now we are left with x. If we pull x common, it is x to the power 4. We have 101 plus 101 c2 x plus something something 4. Okay. So what will happen? The power of 4 will come out to be the power of 4 will come out to be of this form only. Okay. It will be 100 uh, this 4 and plus 1. Okay. So this will not give us any power of x to the power 104. This will not give us x to the power 4. Only this one part will give us. So this is 101 to the power 4 x to the power 4. Put x equal to 1. So we are getting 101 to the power 4, and we are told that this sum is equal to 101 to the power k. Can we say that k equal to 4? This is what it is saying. Find the value of the following. So find the value of the following. So 6 is 0, 12 is 6, 11 is 6. So what can we say? 5, 1, 6, 6, 4, 6. Okay, okay, okay. So we have a term 1 minus x to the power 6 and one term 1 plus x to the power 12. Or we can, what can we say is that hmm, we have to try to convert this like previous equation only. Okay, previous way only. We have to choose some function. This function is not chosen. Okay. So we have to choose in that way only. So how should we go? Uh, 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 it is 1 plus x to the power 2 minus 1 to the power 6. When we expand it, we will get 6c0 minus 1 to the power 0, 1 plus x to the power 12. And then when we are getting 6c1, we are getting 1 plus x to the power 6c1. So we'll get somewhere 10. We have to get it 11. We have to get this 11. 11, 10. Okay. Okay, so if you write it somewhere like this, 6 is 0, 1 plus x to the power 12, and it is 6c1, 1 plus x to the power 11. Okay, 6c2, 1 plus x to the power 10 minus 6c3, 1 plus x to the power 9. 6c4 1 plus x to the power 8. 6c5 1 plus x to the power 7. 6c6 1 plus x to the power 6. Can we try to form some generalized form? Can we do it? If we take 1 plus x to the power 6 common, we are going to get 6c0 1 plus x to the power 6. And here we have 6c1 1 plus x to the power 5. So this is correct, okay? So what are we going to do is that in 1 plus so if we see this thing, it is nothing but 1 plus x minus 1 to the power 6. So 6 is 0, 1 plus x to the power 6. 6c1, 1 plus x to the power. So this is it. And we are multiplying that with this thing. Okay. So this is it. It is simply x to the power 6 into 1 plus x to the power 6. And it is nothing but x plus x square to the power 6. Or we can say it is simply this. And we have to get from here, we have to get the power of uh, 6. So that means from here we have to get 6 is 0. So the answer is 1. Simple. Understood? Let's move ahead. We have to go with the question number 1. MC0 m plus 1 C1 like this, okay? So in this what will happen? In finding this summation we have to go through few tricks. MC0 is what? So our general term is somewhere coming out to be MCR m plus 1 C R plus 1, if you see this, okay? So what will happen? This is m factorial r factorial m minus r factorial. This is m plus 1 factorial m plus 1 m minus r factorial, and this is r plus 1 factorial. If we try to take common, we are going to take m factorial r factorial m minus r factorial out, okay? We are left with m plus 1 r plus 1 m factorial r factorial m minus r factorial. We are left with m plus 1 r plus 1 plus 1. isn't it? Is it so? Okay, so we are not getting any trick. We will get, okay, we are not getting any m plus 1, r plus 1. We are not getting any trick here, okay? So let's take something different. It will be n minus 1. So what can happen? We have mc0. This could be written as m plus 1 mc0. This could be written as m plus 2 m plus 1 c1. Hmm, okay. So the trick begins from here. The trick begins from here. From 1 plus x to the power m, and from 1 plus, okay, wait, from 1 plus x to the power m. No, no, mcr, m plus r. Okay, okay, general term is m plus r cr plus m plus r plus 1 c r plus 1. This is the general term, okay? And now we are trying to solve it. M plus r factorial upon m factorial r factorial plus m plus r plus 1 factorial upon m factorial r plus 1 factorial, which is m plus r factorial m factorial r factorial. We are left with 1 plus m plus r plus 1 upon r plus 1. This is m plus 2r plus 2, which is not going to help us anyway, okay? This is not going to help us anyway. Let's move to second question. We'll come on first question, okay? This is NC3, this up to n. So TR term is what? First term R, n plus R minus 1 C3. This is what we are going to do, okay? This is the summation. This is TR term. Now what will happen? 1 2 3 1 2 3 up to n it will go. summation of this series. Okay, no, what I was trying to do is that if we go to first question, it is 1 plus x to the power m. This is 1 plus x to the power m plus 1. Okay, so we are getting coefficient of x, which is x to the power 0 mc0, x to the power 1 m plus 1 c1. Now we have 1 plus x to the power m plus 2. We are getting coefficient as x square m plus 2 c2. Okay, so this has something to do with integration. Okay, this has something to do with integration. Sum of coefficient of alternate sign we have already done. Will come. Okay, we'll go slowly. Okay, no problem. uh, okay, one. Oh. So what will happen, we are just looking integration type. Okay, use of integration. So use of integration meaning like if we have a function 1 plus x to the power n, which is c0 c1x c2x square c3x cube plus dot 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 cn x to the power n. If we integrate 0 to 1, 1 plus x to the power n dx, we are going to get 1 plus x to the power n plus 1 upon n plus 1, and integration is from 0 to 1. So what will happen, we'll get 2 to the power n plus 1 minus 1 upon n plus 1. And from here if you see integrating, it will come out to be c naught c1 by 2 c3 by 3. It will go up to dot dot cn by n plus 1. So by integration, if we have to find the sum of this sum, we can simply find up to this. Okay, so for this question, we have, so what will happen, in this previous question we got up to this much. Yes, we we are normally getting this thing, isn't it? This thing equal to c naught x square by 2 x cube by 3 x n by n. Okay, so if you see this question, we have 2 square 2 cube. Okay, if we take 2 common, it is nothing but c naught 2 c1 by 2, or we will multiply 2. Okay, it is something we can see that it is x naught x1. Okay, so in this, if we integrate 1 plus x to the power n 0 to 2, it is 1 plus x to the power n plus 1 by n plus 1 0 to 2. So at 2 we are getting 3 to the power n plus 1 minus 1 upon n plus 1. and the rest side we are getting c naught x c1 x square by 2 c2 x cube by 3 dot 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 cn x to the power n at x, just c naught x at c1 x square, it is x plus 1 by n plus 1. So we kept x equal to 2, so we can get 2 c naught, 2 square c naught c1 by 2 dot 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 2 to the power n plus 1 cn by n plus 1. So this is directly using integration we are getting the answer. C naught upon 1 by 3, C naught 3, 3, 3, 3, 3. So 3, 3, 3 everywhere coming. Okay, so we'll take 1 by 3 out. We are getting C naught by 1, C1 by 2, C2 by 3, C3 by 4 plus dot dot dot. Okay, so if you see, this may be integration of 1 minus x to the power n dx. X is from 0 to 1, which is 1 minus x to the power n minus 1, because this is minus, yes, upon n plus 1. This is 0 to 1. So at 1 it is 0, at 0 it is minus 1, at 0 it is 1 to the power n plus 1 upon n plus 1. Okay, at 0 it is, at 1 it is 0, at 0 it is 1 to the power 1 to the power n plus 1, which is 1 upon n plus 1. And if you see the second side, it is 1 by 3, it is c naught minus x plus x, so it is c naught x minus c1 x square by 2, c2 x cube by 3 minus dot dot dot. Put x equal to 1, we have 1 by 3 c naught c1 by 2 x equal to 1, yes, plus c2 by 3. So similarly we got it is this equal to 1 by n plus 1. So this is integration. Now we are going differentiation. Okay, so differentiation, what if we have a function 1 plus x to the power n, which is c naught c1x c2 x square c3 x cube plus dot 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 cn x to the power n. If we differentiate, it is what, n 1 plus x n minus 1. This is c1 2 c2 x 3 c3 x square dot 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 n cn x to the power n minus 1. Put x equal to 1, you will get n 2 to the power n minus 1 equal to c1 2 c2 3 c3 dot 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 n cn. If you put x equal to minus 1, we are going to get 0. N should be bigger than equal to 1. N should be n should be bigger than 1. So it is 0. We are going to get c1 minus 2c2 plus 3c3 3 3c3, okay, 3 and c3 5c3 5c5, okay, 7 and C7. Okay, this is what it is happening. Okay, so we have different way of getting the value in this type of question. We thought of getting what we thought of getting it through differentiation, isn't it? We thought of getting this through differentiation. So let's see how it came. It is something 2n c1, 2n c, 2n minus 1 plus 2 into 2n c2, 2n c, 2n minus 2. It will go up to 2n, 2n c, 2n, 2n c0. So sum of this is what? Sum of this is 2n, sum of this is 2n, sum of this is 2n. Okay, okay. So what about this 2 and 3, whatever we are getting? Okay, this could have been done through one more way. We are trying to use differentiation. Is there any good things? No, using differentiation this can't be solved. What can we do is that we have one r, 2n r, 2n c, 2n minus r. This is what we have. Okay, r equal to maybe 0 to 2n. Okay, so if we see it, we'll have to make r equal to 2n because 0 has no value. We are going to get 2n, 2n minus 1 c, r minus 1, 2n c, 2n minus r. And if you see, the sum of these two is going to be 2n minus 1. So if you ask me, we can say that it is nothing but 2n, 1 plus x to the power 2n minus 1, 1 plus x to the power 2n. Out of this, we are getting the coefficient of 2n minus 1, which is nothing but 2n into 4n minus 1 c, 2n minus 1. So if you compare 18, so this is equal to given as 14, 4n minus 1 c, 2n minus 1. So we can say that this 2n is equal to 18. So n equal to 9. So we are not using differentiation here. Okay, let's see in this we could use differentiation or not. NC0, this. So here also going through differentiation is not clicking in our mind. It is somewhere we are getting r plus 1 minus 1 to the power r, 3 to the power r. So it is simply minus 3 to the power r. Okay, it is c r. Okay, So we have to find somewhere this summation. So we can simply say that it is minus 3 to the power r into r c r. This is the summation plus summation of minus 3 to the power r c r. R is equal to 0 to n. R is equal to 0 to n. Further going, summation r is equal to 0 to n minus 3 to the power r. N is here, n minus 1 c r minus 1. So this r will convert into 1, and this is nothing but 1 minus 3 to the power n. Okay, and this is nothing but n 1 minus 3 to the power n minus 1. This is minus 2 to the power n, and this is minus 2 to the power n. Minus 2 to the power n minus 1 into n plus minus 2 to the power n. So if you see it, it is simply minus 2 to the power n, and it is minus 2 minus n by 2 plus 1. So now based on that, what is happening? N is even. Oh, n is even. N is even. So 2 to the power n will come, and n is even. Oh, so here we got something. Okay. Check this. Okay. N is odd. So this is odd. 3n plus 2 I'm not getting. So this should, I think this should have been, mm, in place of n we would have written n plus 1. So it will become n, and it will become n plus 1. So we'll take minus 2 to the power n common, and we have n plus 1 plus 1 plus minus 2, which is n plus 1 minus 2. So we are getting somewhere this format. That's correct. So check it once. So integration, we did it. Sum of coefficient as a product. So this you should be taking as a homework. Okay, take this as a homework. Sum with alternate sign. So sum with alternate sign in the sense like if it is 1 plus x square, and it will expand at c naught, c1 x, c2 x square plus dot 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 Cn x to the power n, put x equal to minus 1, it will become 0 equal to c naught minus c1 plus c2 minus c3. So they are getting with alternate sign. Yes. So this is the alternate sign. So 1 plus x to the power n. We have c naught c1x c2x square c3x cube plus dot 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 cn x to the power n. So what will happen? Uh, if we try x equal to iota, it is what? 1 plus iota to the power n c naught c1 iota minus c2 minus c3 iota plus c4 dot 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 x equal to minus iota 1 minus iota to the power n. This is c naught minus c1 iota mm, minus c2 minus iota cube is minus and plus c3 iota. So you will find that c1 c3 they are coming opposite, okay, and this is again c4 plus, it will come out to be plus, minus iota to the power 4 will come out to be plus. So if you will add or subtract both of them, we are going to get 1 plus iota to the power n minus 1 minus iota to the power n. So it is nothing but 2 c1 minus c3 plus c5 dot dot dot. If you play see here, it is, if you divide by root 2, multiply with root 2, so it is root 2 to the power n, and it will become e to the power iota pi by 4 minus e to the power minus iota pi by 4, and it is 2 time of our required thing x. So this is 2 to the power n by 2 minus 1. Okay, and here we have cos pi by 4, which is, it is n pi by 4. Yes, n pi by 4, n pi by 4. So cos n pi by 4, cos minus n pi by 4 cancel. So we'll get 2 sine n pi by 4, which is our required amount x. And here we are getting somewhere 2 to the power n by 2 sine n pi by 4 is equal to x, our required equation. So we could prove it normally, isn't it? Moving ahead. Okay. Okay. Now in first what will happen? We have this generalized term. So it is what? 2r plus 5 cr. We have to find the sum r equal to 0 to n. So it is somewhere 2 n minus 1 c r minus 1 n will come down, summation plus 5 summation cr. This is 5, okay? So this is some nothing but 2n, 2 to the power n minus 1, and it is 5, 2 to the power n, which is nothing but 2 to the power n, n plus 5. So we got first one. Second one, it's a integration. We can say it's an integration. We have already solved this question. Third one, third one, uh, so we are getting that this thing is always coming out to be n. Yes. And third one also we have solved. If you remember, we have 1 plus x to the power n. So if it is nc0, n plus 1 c n, and it is nc1, we have solved this question. If you remember, nc n minus 1, this is going up to much. We can simply say that it is nc0, 1 plus x to the power n plus 1. It is nc1, 1 plus x to the power n, and dot dot dot. So we have taken 1 plus x to the power x common. We have nc0, 1 plus x to the power n, nc1, 1 plus x to the power n minus 1 plus dot dot dot. And we have to get the coefficient of x to the power n. Okay, this is what we are trying to do. So we can say that it is something like 2 uh, 1 plus 1 plus x, 2 plus x to the power n, and 1 plus x. We have to get the coefficient of n. We have to get coefficient of x to the power n. So 1 could be when 1 is multiplied, it is nc n 2 to the power n, and 1, it is x, it is nc n minus 1 2 to the power, when it is 1, it is ncn 2 to the power 0, it is 2 to the power n minus 1. So this is what I have told. So it is what nc n, which is 1, which is 1 plus 1 plus, what is happening is that, listen, we are saying that in this expansion we have to find the power of n. So it could be 2 plus x to the power n plus x into 2 plus x to the power n. Okay, so from here we will get ncn x to the power n 2 to the power 0. Okay, and from here we'll get nc n minus 1 2 to the power 1, which is nothing but 2n plus 1. Okay, and we have, with this we have multiple of x to the power n. So if you put it's not messed up, it's nc0. So if we put x equal to 1, we are going to get these terms. So it is 2n plus 1. Okay, check it. Okay, this is what we should be getting, and then check it. We have done this question earlier. We are moving to question number 4. Okay, so 2c2 3c2 up to nc2. Okay, we are getting n plus 1 c3. So question number 4, we should be getting the trick. Okay, we have r c2 r plus 1 c2 dot 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 n c2. We have to find this trick. What is this trick of r? Hmm. We are not getting this trick. Okay, in previous question also we are facing some trick issue. rc1 1c1. Okay, what will happen? We can do one thing. This is 2c2, so we can do 2 by 2 1c1. We can do 3 by 2 2c1. Similarly, we can do 4 by 2 3c1 dot 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 n by 2 nc1. So if you remember, 2 is coming down and we have 2 plus 3 into 2 3 into 4, and it is like 4, it will, here it will come 4c1, and we will have 5. 1 into 2 2 into 3 3 into 4 4 into 5 dot 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 n minus 1 into n. So our summation is coming out to be somewhere r plus 1 by 2. R is varying from 1 to n minus 1. Okay. This is n minus 1. Okay. N minus 1. So this is 2 summation r square plus summation r. We can simply get it as n plus 1, 2n plus 1, n plus 1. This is by 6. This is by 2 whole over 6. And we can simply get it as n minus 1. This is 2. Okay. The summation, simple summation. Okay. And 2n minus 1 by 6 plus 1 by 2 whole 2. So this is the solution. Let's try some previous question where we faced some problem. Here we face some problem. So this is also moving ahead and this is also moving ahead. So this question became simpler for us right now. Yes, it will become n by 3, n minus 1 by 2, and this is somewhere n minus 2 c1 dot dot dot. So tr term will come out to be if it is r plus 1. So we are getting r by 3, r minus 1 by 2, r minus 2 c1. This is the tr term. So we are simply getting r minus 1, r minus 2 by 6. This is summation. We can get it as 1 by 6 summation r square minus 3r plus 2, further summation 1 by 6. R cube is, r is from 2, r is from 3, r is from 3 to we'll get 2n minus 2, 2n minus 3. Okay, so 2n minus 3 will become r equal to 3 to n. Okay, and this is r cube summation minus 3r square summation plus 2r summation. So this is how we are coming. In this, if we go, it is mc0. Here it is m plus 1. So this is mc0. This is m plus 2, m plus 1. So it is like this, it is coming. Okay, we can find that it is 1, m plus 1, m plus 1, m plus 2. Okay, so this question is important. We'll come to this. Let's move ahead. In this question 1, this, if you see this, it is nothing but 3c1, 3 square c2, 3 cube c3 dot 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 3n cn, and minus of summation of c1 to c2 2 square dot 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 cn by 2 to the power n. So this is it. If you see there, it is 3 to the power 0, c0 will add it and will subtract it. So this is nothing but 1 plus 3 to the power n. That means 4 to the power n. Is it so? So 4 to the power n minus 1 is the outcome for this one, and minus will have c naught by 2 to the power 0 and will have minus 1, and other than that we have c naught to the power 1 c2 2 square dot dot dot. So we have 4 to the power n minus 1 minus minus minus, this is 1 plus 1 by 2 to the power n, which is 3 by 2 to the power n. Now if you solve it, it is coming out to be 2 to the power 2n minus 3 to the power n 2 to the power n, which is nothing but 2 to the power 3n minus 3 to the power n upon 2 to the power n. So question number 1 done. Question number 2, we are trying to take it here only, okay? The general term is what? R, NCR, NCR minus 1. Okay? We have to do the summation of this one. So if you solve it, it's simply R, N factorial, R factorial, N minus R factorial, N factorial, N minus R plus 1 factorial, R minus 1 factorial. So N cancel, this cancel with this one, this cancel with this one, this is cancelled. We are simply getting N minus R plus 1, and we have to do the summation of N minus R plus 1, which is nothing but N plus 1 summation minus R summation, and which is nothing but N plus 1. R is 1 to N. R is 1 to N. So it is N plus 1, and this is N plus 1 by 2, which is nothing but N plus 1 by 2. Got it? So question number 2 done. Question number 3. Question number 3. C note C1, C1 C2, C2 C3 dot 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 Cn minus 1 Cn. We have to find this thing, isn't it? So what will happen? If you remember NCR plus 1 is N plus 1 CR. Similarly, N plus 1 C2, N plus 1 C3. So dot 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 N plus 1 Cn. If you take out this, it is N plus 1 by 1 NC0, N plus 1 2 NC1 dot 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 N plus 1 and this is multiplication, okay? NC N minus 1. So it is nothing but N plus 1 to the power N minus 1 C naught C1 dot 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 C N minus 1 upon N factorial. If you see, it is something like this. Okay, it is C naught to Cn minus 1. So there is n terms here, okay? And all are correct, okay? Moving to fourth one. 2 C naught, okay, okay, boss. So we have TR term as minus 1 to the power r plus 1 C r. We have to find the sum of this. Summation of TR. We can do it as r minus 1 to the power r n by r n minus 1 C r minus 1 plus summation of minus 1 to the power r CR. This r cancel. We have n out, and this is n minus 1 C r minus 1 to the power r 1 to n. So this is nothing but the expression of 1 minus x to the power n, where x is 1. So this will come out to be 0. Similarly, this is nothing but 1 minus x to the power n, where x is equal to 1. So this is also 0. Moving ahead, the fifth one. Fifth one is simple integration. Sixth one is simple. Sixth one is simple. 1, 2, 2, 3, 3, 4. Okay. 1, 2, 2, 3. Okay, we have to take general term. General term is fifth one. Okay. General term is what? 2 to the power r plus 2. This is sixth one. Okay. 2 to the power r plus 2 CR upon r plus 1 r plus 2. And we have to do the summation of those. Okay. Summation of this beginning from r equal to 0, r equal to 0 to n. So what will happen? This is simply 2 to the power r plus 2, and this is n factorial r factorial n minus r factorial, and we have r plus 1 r plus 2. If we move further, we will find that it is summation r equal to 0 to n 2 to the power r plus 2 n factorial upon r plus 2 factorial. This r factorial and r plus 1 r plus 2 will become r plus 2, and we have minus. If you make it r plus 2, we'll have to add 2. So similarly, we'll do n plus 1 n plus 2 and divide by 1 upon n plus 1 n plus 2. So if you see further, it is simply r equal to, right now keep it 0. We'll see what is the condition happening. Okay. It is 2 to the power r plus 2. This is n plus 2 c r plus 2 whole divided upon n plus 1 n plus 2. So when r is 0, when r is equal to 0 to dot 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 up to n, it is going something like 2 to the power 2 n plus c, n plus 2 c2 upon whole upon n plus 1 n plus 2, which is constant. This is 2 cube n plus 2 c3 dot 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 2 to the power n plus 2 n plus 2 c n plus 2. So if you see that, if we add 2 to the power 1 n plus 2 c1 and 2 to the power 0 n plus 2 c0, we'll have to subtract both of them, which is minus 1, and this is minus 2n minus 4. So it is nothing but, if you see, it is 1 plus 2 to the power n plus 2 minus 2n minus 5 upon n plus 1 n plus 2, which is nothing but 3 to the power n plus 2 minus 2n minus 5 upon n plus 1 n plus 2. Got it? I think we got the answer. Yes. Sum of coefficient of even and odd sign. So what will happen if we have 1 plus x to the power n? It will come out to be c naught c1x c2x square dot 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 cn x to the power n. Similarly, we have 1 plus x. Okay, we have like this. Okay, we'll put x equal to 1. We'll get what? 2 to the power n equal to c naught c1 dot 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 cn, and x equal to minus 1. It is what? 0 equal to c1 minus c naught minus c1 plus c2 minus c3 plus dot dot dot. If we add both of them, if we add, we are going to get this thing, isn't it? We are going to get something c naught c2 c4 dot dot dot. And if you see one thing, all terms are having negative signs. So if we take it that side, can we say that c1 plus c3 plus c5 plus dot 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 is equal to c naught c2 c4 dot dot dot? Can we say this? And similarly, can we say that this part is equal to 2 to the power n minus 1? So that's all. Product of the coefficient. If we have 1 plus x to the power n and 1 plus x to the power n, if we are getting coefficient, we'll get in this form c naught c1 c2 dot 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 cn, and we are getting somewhere c naught c1 c2 dot 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 cn. Okay, so some of the coefficient will come out to be c naught square c1 square dot 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 cn square. Similarly, c naught c1 multiple, it will be somewhere like summation summation I equal to 0 to n j equal to 0 to n ci cj. Now if we have to find this value, what we do normally, we do simply 1 plus x to the power 2n, and we get somewhere 2n c0 2n c1 dot 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 2n cn. So we consider that the coefficient whose power will be 0 is going to represented by this one. The coefficient of x square available in this is going to have 2n c2 value. So that is what we are trying to do. Okay, so we can say that 2n c0 represents constant term in 1 plus x to the power n, 1 plus x to the power n. So this is the meaning that we are able to find the coefficient of the product of two binomial theorem very easily. So this trick is helping us to get this thing. Okay. Now for example, if we are here, C naught, C3, C1, C4. So if we see it is C naught, it is C n minus 3. This is C1, C n minus 4. If you keep on going, it is C n minus 3, C naught. If you see, the sum of this is what? N minus 3. The sum of this is what? N minus 3. The sum of this is what? N minus 3. So we can see that these are outcomes of this. From this, we are getting the coefficient of x to the power n minus 3. So can we say that it is nothing but 1 plus x to the power 2n, and the coefficient are nothing but 2n c n minus 3. So this is it. Similarly for second one, okay, if you see, it is nothing but c naught c n minus r, c1 c n minus r minus 1. So the sum is somewhere coming out to be n minus r, n minus r, and it will go move up to that. So now we are experts saying that it is 2n c n minus r. Got the answer? So now we are expert, isn't it? So third one we will be solving here. C naught square minus C1. Okay. So we are told that it's C naught square minus C1 square, C2 square minus C3 square plus C4 whole square dot dot dot. What is this value? So can we say that it is nothing but C naught Cn C1 Cn minus 1 C2 Cn minus 2 minus dot dot dot. The sum of this is what? N. This is n. This is n. Can we say that it is nothing but 1 is 1 plus x and 1 is 1 minus x. This is the coefficient of this one. From here we are finding coefficient of x to the power n. So what will happen? This could be simply written as 1 minus x square to the power n. Okay. Now case 1. If we have to find this thing, can we say that nc n by 2 minus x squared to the power n by 2, which is x to the power n. Case 1, if n is not even n by 2 is not possible, so the answer is 0. Case 2, n equal to odd, so it is nothing but nc n by 2 minus 1 to the power n by 2. This is what they are trying to say. Now we are on IIT advanced question. Okay, let's do this. Based on product, we are on IIT advanced question. IIT JEE means, okay. This is n minus k. Okay, 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 okay. If you see, it is nc0 2 to the power k nck minus nc1 2 to the power k minus 1 n minus 1 c k minus 1. It is something like this, okay. If you see that if it is 1, this is minus, if it is 3, it is again minus. That means, can we say that it is nc0? If we tell it, it is 1 plus 2 to the power k to the power n, okay. This is nc1 1 plus 2 to the power n minus 1, okay. Because the sum of the coefficient is coming k, okay, the output is coming out to be k, so this will keep on moving. Right now we'll put x in place of 2, so it is nothing but nc0 1 plus x to the power n nc1 1 plus x to the power n minus 1 dot dot dot. Yes. Okay. We have 2 to the power k, yes, nck. Hmm. Now what will happen if we try to see, it is nothing but 1 plus x minus 1 to the power n. This is the expansion. This expansion is from here. Yes, nc0 1 plus x to the power n minus 1 nc1. So this is the expansion, which is nothing but x to the power n. Okay. And what is happening is that this is simply x to the power n. So we are looking to get the coefficient. So what will happen? This is simply, okay. So up to here we got it, yes. And then now we have to see. Hmm, we have nc0 1 plus 2 to the power n, yes. We have to get it nck. Prove that, okay. One more thing we can do it is that we'll make this nck, okay, nc0. We can make this nc n. In this expansion, we are trying to find 2 to the power k. So we have nc0 2 to the power k. We got that this function is coming from here. Hmm. If we take 2 to the power k common, if we take 2 to the power k common, we can simply say that it is nc0 2 to the power 0 nck. This is 1 by 2 to the power 0. You can say it is 1 by 2 to the power 1 nc1 nck minus 1 plus dot dot dot. We can say it is 2 to the power k and this is minus 1 by 2 minus 1 by 2 to the power n. Wait, We are trying to do very nicely, okay? So what will happen if we take 2 to the power k? If we take 2 to the power k common, we are simply getting nc0 1 by minus 1 by 2 to the power 0, nck 1 by 2, nc1 n minus 1 ck minus 1 dot dot dot. It is nothing but 2 to the power k, and this is 1 plus x to the power n 1 plus x minus 1 by 2 to the power n. So nc0, so this we will get simply like 2 to the power k x plus 1 by 2 to the power n. Okay, or from here we were getting x to the power n. From x to the power n, finding the coefficient of x to the power k. From here we have to find the coefficient of x to the power k. So can we say that it is nck to the power x to the power k? It is x to the power n. So we are saying that coefficient of finding x to the power k is this thing, nck only. This is what we are saying. This whole result is outcome of x to the power n, and from every term we are getting x to the power k, 2 to the power k. So we can say that it is nck. So nck is our answer. Moving ahead. Okay, okay, okay. Now we are on lecture 4. So we are on lecture 4. So I am giving you 2 minutes of break. We'll come back. This is the last lecture. Now we are on finding nature of integral. Okay, so we are on finding the nature of integral. So we did good sums, good numbers of sums. Okay, which was really great. Finding the nature of integral. So what will happen if we are given some number n, which is a plus root b to the power n, okay, where n belongs to natural number. Okay, now we will have some condition. We'll consider and s, which will be written as a minus root b to the power n, or n dash will be root b minus a to the power n. So it will depend if a is bigger than root b, so we'll go with the first one, or if root b is bigger than a, we'll go with the second one. Overall, something going inside bracket should be positive. That is what I am trying to say. Okay, so this is step 1. Step 2, we will have either n plus n dash or n minus n dash. This operation will have either of the operation to get like even odd result. Okay, even odd result, or maybe greatest integer, finding greatest integer. Okay, so what if we have question like, if we have question like 2 plus root 3 to the power 100 is equal to I. So greatest integer of this equal to I. So I equal to what? So for this case we have to follow this. Okay, for this type of question. So if I am solving this question, what will I do? I have considered this as 2 plus root 3 to the power 100. Root 3 is 1.7. So I will consider n dash as 2 minus root 3 to the power 100. Okay. So now what will happen? Odd power of root 3 will get minus. Even power will get added. So if I do n plus n dash, it is 100 C0 2 to the power 100 root 3 to the power 0 100 C1 2 to the power 99 minus root 3 plus dot dot dot, and from here we have 100 C0 2 to the power 100. Okay, this is plus 1, this was n, now this is n dash, this is minus 100 C1 2 to the power 99 root 3 plus dot dot dot. We'll find that this term and this term is getting cancelled, and we are overall getting 200 C0 2 to the power 100 100 C2 2 to the power 98 3. So these are all rational we are getting. So we have n dash is what? Integer minus 2 minus 1.7, which is a fraction. Fraction to the power 100 is fraction. So what will happen? So what will happen is that now we have n, which is equal to 2 lambda minus fraction. So can we say that greatest integer of n is odd? Okay, can we say this? So for this reason we are using this thing. Okay, greatest number less than equal to. So based on previous question we can solve it, or I am helping you to solve it. Root 2 plus 1 n dash will be root 2 minus 1 to the power 6. Now n dash, this is 1.4 minus 1, this is fraction, n dash is fraction. So it is 6c0 root 2 to the power 0, 6c1 root 2 to the power 5, 6c2 root 2 to the power 4 plus dot dot dot, and from here we are getting 6c0 root 2 to the power 0 minus 6c1 root 2 to the power 5 plus. So if we add them we are getting 6, 2 times of 6c0, 6c2 2 square plus dot dot dot. So this is n plus fraction. So n is what? 2 lambda minus fraction. So greatest integer less than or equal to. So in that which we are finding this thing. Oh, oh, oh. So what will happen? So n is fractional, okay? This is what happening. Okay, so this value is what? 2 into 6c0, 6c2, 2 square plus dot 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 minus f. So we have to find this sum. So we remember that this 1 plus x to the power 6. We have to find these values, okay? So sum of even. We have studied that 1 minus x to the power n. We have to find these values, isn't it? So we have to calculate these values. So we should be knowing to calculate, okay? So let's calculate it. So this is what? 2. We should be knowing this trick, okay? This trick we have to know it, okay? We have 2 plus 1 to the power 6. And we have 2. Okay, 0. It is 2 only, okay? It is 1. It is 1, okay? Root 2 whole square, yes. So it is root 2 whole square. We have to calculate this one, okay? 6 is 0 is 1. We can say that greatest integer is odd. Now find that number. So finding that number is 2 to the power 1, 2 to the power 2. This is 6 is 0, 6c2, 2 to the power 1. It is going like this, okay? 6c4, 2 square, 6c6, 2 cube. This 2 and minus f. 1 plus 8 plus this 15, this 64 is same thing with 60, and this is what it is: 90, 99, 198 minus f. So we should be having 197, which is less than or equal to. Got it? Negative or fractional part. Fractional index. Okay, negative or fractional index. So now we are proceeding with that. So what will happen? It is nothing but if we have 1 plus x to the power minus n. So this is negative index. Okay, how should we open this? We'll do minus n c0 x to the power 0 minus n c1 x to the power 1 minus n c2 x to the power 2 plus dot minus n cn x to the power n. This is the way we'll go. Okay. Okay. Now how to find minus ncr? It is simply minus n factorial minus n minus r factorial r factorial. Now minus n is what? Minus n minus 1 minus n minus 2 minus n minus 3 minus n minus r factorial upon minus n minus r factorial. So what will happen if we add one term to this? So it will be somewhere, let's say it is 1, then it is minus n minus r factorial. So we are left with minus n minus 1 minus n minus r plus 1 upon r factorial. Now what will happen? We'll pull out minus outside. Okay, so it is appearing somewhere from n plus 1 n plus r minus 1 upon r factorial, if you see it. So for that reason, what will we do? We'll multiply with n minus 1 factorial and divide with n minus 1 factorial. So we are simply going to get n plus r minus 1 factorial upon r factorial n minus 1 factorial, which is nothing but n plus r minus 1 c r. Okay, n minus 1 n plus 1 n plus r minus 1 upon c n in cr. Okay, and we can simply say that this is nothing but tr plus 1 term, which is n plus r minus 1. Okay, I think you got it. It is minus 1 minus 2 minus 3 minus 4. We are going somewhere like this. Yes, yes, we are correct. I was just trying to validate. Okay, so now this is it. Okay, now what will happen? So this is negative and we are going with fractional. Yes, So when we are going with fractional, okay, fractional index, okay, fractional index, what will happen? We have 1 plus x to the power n. We can simply expand it as nc0 x to the power 0, nc1 x to the power 1, nc2 x to the power 2 dot 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 ncn x to the power n. So it has the general thing. Okay, it has the same thing. Okay, and one more thing. Note, if we have 1 plus x to the power n and and x mod x is less than 1, we can simply say that it is nothing but 1 plus nx. Okay, and one thing is that n belongs to rational number and n is not equal to whole number. Okay, it should be rational number, then we can write it in this way. Got it? And few expansion that we have to remember. Okay, I think we have some space or not, let's see. Okay, we will restore multinomial. So few things to remember. So now in this we have already proved this thing. Yes, tr plus 1, it is n plus r minus 1 cr. So we already proved this one. Okay, so we have to write few notes that 1 plus x to the power minus 1, can we say that it is 1 minus x plus x square minus x cube plus dot 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 up to infinity. Okay, if we have second thing 1 minus x to the power minus 1, can we say that it is nothing but 1 plus x? I think plus x, it's like infinite gp if you remember. Now third one, if it is 1 plus x to the power minus 2, then what to do? So we have simply minus 2 c0 x to the power 0 plus minus 2 c1 x to the power 1 minus 2 c2 x to the power 2, this way of expansion. Okay, similarly for 1 plus x to the power 1 minus x to the power minus 2, we have minus 2 c0 minus x to the power 0 minus 2 c1 minus x to the power 1 plus dot dot dot. Okay, got it? So if x is so small such that its square and higher power may be neglected, square, okay, then find the value of 1 minus 2x. Okay, we have to find this value. So We can do simply 1 minus 2x to the power 1 by 3, 9 plus x to the power minus 1 by 2, 1 plus 5x to the power minus 3 by 2, 9 plus x to the power 1 by 2. Okay, minus 1 by 2. So if you do the expansion, it is 1 minus 2 by 3 x. If we go with x square, it is going to be getting neglected. It is 9. Okay, wait. We'll take 9 common. 9 to the power minus 1 by 2. And this is 1 plus x by 9 to the power minus 1 by 2. It is 1 plus 5x to the power minus 3 by 2. We'll take 9 common. This is 1 plus x by 9 to the power minus 1 by 2. This is 1 minus 2 by 3 x. This is 1 by 3. And this is nothing but 1 minus x by 18. And this is nothing but 1 minus 15x by 2. This is 1 by 3. This is 1 minus x by 18. This is 1 by 3. If you multiply, it is 1 minus x by 18 minus 2x by 3. We are getting plus 2 by 3 into 1 by 18 x square. We'll neglect that. And we have 1 by 3 here. 1 minus x by 18 minus 15x by 2 plus 15x square by 36. This is going to be neglected. This is 1 by 3. 1 minus 6 multiply 13x by 18. We have 1 by 3. 9. 9 5s are 15 9s are 135. 135 136 by 18. Okay, and it is nothing but 1 by 3. 2 minus 149x by 18. So this is how it is going to come. Okay, find the possible set of values of x for which the expansion is valid in ascending order of x. So what will happen? We'll take 3 to the power 1 by 2 common, and it is 1 minus 2x by 3 to the power 1 by 2. So we should be getting that this mod minus 2x by 3 should be less than 1. So we can say that mod x is less than 3 by 2. We can simply say that x is between minus 3 by 2 to 3 by 2. This is very good question. What will happen if we consider 1 plus x to the power n? if we see the expansion, this is what? Uh, NC0, NC1, NC2, x square dot dot dot. Hmm. So NC0 is 1, yes. And this is what? N x to the power 1 and n minus 1 by 2 factorial. Next is what? N minus 1, n minus 2, 3 factorial, x to the power 3. So if you compare why this is this, okay? 1 plus x to the power n. So it is 1 plus x to the power n minus 1. This is nx plus n minus 1 by 2 x square n minus 1 n minus 2 x cube by 3 factorial plus dot dot dot. So this is equal to even y, yes. Now in y, if we compare, if we consider this is x square is 2 by 5 square, so nx is equal to 2 by 5 and n minus 1 x square by 2 factorial is 1.3 2 factorial 2 by 5 whole square. Yes. So this is 1, this is 2. 2 factorial gone. X square could be written as 2 by 5 whole square 1 by n whole square and n minus 1 equal to 1 into 3 2 by 5 whole square. This is going to be get cancelled. Further moving ahead, we are getting n minus 1 upon n equal to 3. If we see it is n minus 1, 3n. Now from here we get n equal to minus 1 by 2. Okay, we are trying to validate this step also. So n equal to minus 1 by 2. This will be what? Minus 1 by 2, minus 3 by 2, minus 5 by 2, and this is 3 factorial 2 by 5 whole cube. So minus minus plus minus, so we have minus overall. Oh, oh, oh. N equal to minus 1 by 2. Okay. we are getting n equal to minus 1 by 2. So what is wrong here? So this whole we are getting. Okay, if we want to get this value, okay, no problem. Uh, so n is minus 1 by 2. X could be minus 2 by 5. Okay, x could be minus 2 by 5. So x is also negative, n is also negative. Then this is possible. So then that is it. Then this is possible. Okay. So we simply got that y is equal to, this is y, yes. So we have to do y square plus 2y. Okay. So y is something distinct. So if you see, it is nothing but 3 by 5 to the power minus 1 minus 1. Now we'll do y plus 1 whole square equal to 5 by 3. So we are getting that y square plus 2y equal to nothing but 2 by 3. Okay. So this is what we are getting. It is very good question. X to the power 5 in the expansion. It is nothing but 2 minus 3x 1 minus x to the power minus 3. We'll use formula. So this is 2 1 minus x to the power minus 3, and this is minus 3x 1 minus x to the power minus 3. So it is 2. We have known that this is n plus r. So we got that it is n plus r minus 1 cr minus 3. It should be x to the power 50. So minus 3 is n plus r 49 minus 1 c 49, and here it will be r equal to 50. So it is 253 minus 1 c 50, and this is 351 c 49. So it is something 252 c 50 351 c 49. So this is the coefficient. X to the power 6 in the expansion. Uh, minus 5 by 2 c 6 minus 2x to the power 6. We have to go with minus 5 by 2 minus 5 by 2 minus 1 minus 5 by 2 minus 2 minus 5 by 2 minus 3 dot 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 minus 5 by 2 minus 5 minus 5 by 2 minus 6 factorial, and we'll divide it by 6 factorial minus 5 by 2 minus 6 factorial. So this is getting cancelled. We are somewhere getting 0 1. We have 5 terms, isn't it? 6 terms. So we are getting 5 by 2, 7 by 2, 9 by 2, 11 by 2, 13 by 2, 15 by 2. 1 2 3 4 5 6. Okay. And we have 6 factorial. So we have to solve it. And this is multiplied with 2 to the power 6. 2 to the power 6. So 1 2 3 4 5 6 cancel. We are left with 5, 7, 9, 11, 13, 15. And here we have 6, 5, 4, 3, 2. So 5, 5 cancel. 9 3s are 3 2s are, and we have nothing more. It is simply 16 77 into 13 into 15. This is the answer. Simply solve this one. Simply solve this one. Now this one. X is very large. So what will happen? We can write this as simply 1 upon 1 plus y by x. And this is 1 upon 1 or minus y by x. If you see it, it is simply 1 plus y by x to the power 1 by 2, and this is 1 upon 1 minus y by x upon 1 by 2. So if you see, it is nothing but 1 minus y square by x square to the power minus 1 by 2, and this is nothing but 1 plus 1 by 2 y square x square. So if you compare, k is equal to 2. If you want to expand this one, it is nothing but 1 plus x whole square 1 minus x minus 2. So it is 1 plus x square plus 2x, and it is 1 plus x minus 2. So with the first, we'll get 2 plus 4 minus 1, c 4. 2 plus 2 minus 1, c 2. This 2, 2 plus 3 minus 1, c 3. So this is simply 5c4, 3c2, 4c3. This is the coefficient, which is nothing but 5, 3, 8, 16. Expansion of this valid in the interval. So x is between, it is simply 3x by 2 plus 1 minus 1 by 2. So 3x by 2, in this 3x by 2 mod should be less than 1. So x is between 2 by 3 to minus 2 by 3. Okay. Now this question, the value of a1 to a2, 2a2, 3a3. Okay. So what will happen? It is 1 plus x square dot 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 x to the power p to the power 6. It is nothing but 1 x to the power p plus 1 minus 1 x minus 1 to the power 6, which is nothing but x p plus 1 minus 1 x minus 1 to the power minus 6. Now if you do the expansion, it is nothing but it will come up to 6p. That's okay. Okay, we don't have to do this much. Okay, simply differentiate this one. If we differentiate this function, we are going to get 6 1 plus dot 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 1 plus x square plus x to the power p. This is 5, and the differentiation of this is 1 plus 2x plus 3x square 4x cube plus dot 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 p x to the power p minus 1. And this side we have a1 2a2 2 a1 2a2x 3a3x square plus dot 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 6p a6p x to the power 6p minus 1. Put x equal to 1. We'll get 6 1 2 3. It is p to the power 5 p plus 1 6. It is p plus 1 to the power 5, and this is nothing but 1 plus 2 up to p. And here we have a1 2a2 3a3 dot 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 6p a6p. This is nothing but 6 p plus 1 5. This is p plus 1 by 2 is equal to a1 2a2 3a3 plus dot 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 6p a6p. So this is nothing but 3, this whole value upon p plus 1 to the power 6. So the answer is 3. So here we used the differentiation method. This one solve as a homework. Now we are on multinomials. Okay. So multinomials means expansion of expansions of expressions with having more than two dissimilar variables. Example: x plus y plus z plus w to the power 5, x square y 1 by z, x square z to the power 7, etc. So what will happen? We are taking one example, x plus y plus z plus w. So it is 5. So how will this expand? It will expand in the form 5 factorial, 0 factorial, 1 factorial. So what will happen? We are distributing 5, okay? So the general term will come out to be general term as 5 factorial, r1 factorial, r2 factorial, r3 factorial, r4 factorial, x r1, y r2, z r3, w r4, where r1 plus r2 plus r3 plus r4 is equal to 5. So this is the extension. So this r1, r2, r3, r4 will vary, and ri is bigger than equal to 0 and less than equal to 5. So any term will vary like this, okay? So we can't show you the real expansion, isn't it? So if we are given this question, okay? So how should we solving this question? So what will happen? We have general term tr plus 1 term. We'll have 10 factorial, r1 factorial, r2 factorial, r3 factorial, r4 factorial. This is a to the power r1, b to the power r2, c to the power r3, d to the power r4. If you compare, we have to put this is minus b minus c. So this is 10 factorial, r1 is 2 factorial, r2 is 3 factorial, r4 is 4 factorial, r3 is 4 factorial, r4 is 1 factorial. And here we have a to the power 2 minus b whole cube. So minus will come out. So minus will come out. So minus c to the power 4. So c4 d1. So the coefficient is nothing but this thing. Coefficient is nothing but minus 10 factorial upon 2 factorial, 3 factorial, 4 factorial. Got it? So terms independent of x. So we have some general term 11 factorial, r1 factorial, r2 factorial, r3 factorial, okay? So 1 to the power r. So we are playing with x, r1. This we'll keep it r2, okay? 7 by x, r2. So if you see that it is nothing but 11 r1 factorial, r2 factorial and r factorial with x to the power r1 minus r2 7 r2 factorial. So it should be independent. That means r1 should be equal to r2. Okay, and r plus r1 plus r2 should be equal to 11. So if r1 is equal to r2, can we say that 2r1 is equal to 11 minus r? So if r is 0, r1 is 5, r1 is nothing, not possible. So r is 1, r1 is 5, r is 2, not possible, r is 3, r1 is 4, r is 5, r1 is 3, r is 7, r1 is 2, r is 9, r1 is 1. So that's all. This much numbers are possible. So terms independent of x. So what are the terms which are independent? So it will be what? T 0 plus 1. No, these are the term. Like when r is 0, r is 5, 1, 2, 3, 4, 5. These are the term which is independent of x. So number of terms in the expansion of a plus b plus c plus d plus e. So what will happen? If you remember, we have x1 plus x2 plus x3 plus x4 plus x5. It should be equal to n. So they should be getting none, some, none, some, or all values. That means x1 could be 0 or maybe in between 0 to n or can be equal to n. So in this trick we will do what? N plus 1, 2, 3, 4, 5. 5 minus 1 c 5 minus 1, which is nothing but n plus 4 c4 or n plus 4 cn. So option A is correct. This we can solve it normally. So we'll get 2 to the power r1. This is r2. So we'll have to keep the value and try to make it 17. This we can easily solve it. This we can solve it easily. This one I will be solving. This one I will be solving. Okay, I will be solving. Okay, okay. This one I will be solving. Okay. So a naught a2. So if you put x equal to iota, it is what? A naught a1 iota minus a2 minus a3 iota plus a4 plus a5 iota. We are trying to just visualize, okay? Minus a6 minus a7 iota. Okay, we are trying to visualize up to this much, okay? If we put x equal to minus iota, this is a naught a1 iota plus a2. Okay, okay. No, this is also minus, okay? This is minus iota whole square plus minus iota whole square. This is plus minus iota whole cube. This is plus minus iota whole cube. Okay. Uh, Minus iota whole cube. X cube. Minus will come. This will become plus a3 iota minus a4. Okay. Hmm. X equal to iota minus iota whole square minus iota whole cube minus iota whole 4. This is minus iota to the power 4, which is plus. Okay. So this is what we are getting. Yes. If we add all of both of them, I think we are going to get 2 a naught minus a2 plus a4 minus a6 plus a8 minus a10, which is what? 1 plus iota to the power 10, 1 minus iota to the power 10. Okay. And in case if we minus 1 plus iota to the power 10 minus 1 minus iota to the power 10, we are going to get 2 iota common, maybe a1 minus a3 plus a5 minus a7 plus a9. Okay, we got it. Yes, yes, we got it. So this is 1, this is 2. So for 1, we are dividing with root 2, multiplying with root 2. It is 2 to the power 5 e to the power iota 10 pi by 4 plus e to the power minus iota 10 pi by 4, which is q, this value a naught, a2, a4 minus a10. And similarly in second one we are getting 2 to the power 5 e to the power iota 5 pi by 2 minus e to the power iota minus iota 5 pi by 2, which is 2 iota a1, a3, a5, a7 dot dot dot. Now what will happen? First, going for 1. First, going for 1. This is what? Cos pi by 4, cos pi by 4, cos 5 pi by 2, cos 5 pi by 2, 2 to cos 5 pi by 2 plus iota sin pi by 5 pi by 2. This is cos 5 pi by 2 minus iota sin pi by 2. So this is going to be cancelled. This is going to be 0. And this one is 0. Second one, we have 2 to the power 5. Cos 5 pi by 2 is 0. Sin 5 by 5 pi by 2, which is iota into 1, and this is minus of minus, which is again iota. So we are going to get 2 iota a1, a3, a5, a7. So this 2 iota gone. Whole square of both of them and sum. So 0 whole square plus 2 to the power 5 whole square is our required solution, which is 2 to the power 10. That's all. Number of rational term. So general term is going to be 6 factorial, r1 factorial, r2 factorial, r3 factorial, 1 to the power r1, root 2 to the power r2, root 5 to the power r3. So r1 by 2 should be integer, r3 by 2 should be integer, and r1 plus r2 plus r3 should be 6, and r1, r2, r3 should be less than equal to 6, bigger than equal to 0. Okay. Now if r1 is 0, r3 is 0, we are getting integer. If r1 is 2, r3 is 2, we are getting integer. What we are trying to say that r1 is 2 lambda 1, r3 is 2 lambda 2, and r is r, which is 6. Okay. So if r is 1, r could be 0. So this could be what? This could be 0, 2. This whole value could be 0, 2, 4, 6. Now when r is 0, okay, wait. When r1 is 0, r3 could be 0, when R1 is 0, R3 could be number of rational terms, okay, could be 2. When R1 is 0, R3 could be normally we can say 0, 2, 4, 6. When R1 is 2, R2 could be 0, 4, 2. It cannot be 6. When R1 is 4, R2 could be 0, 2. When R1 is 6, R2 could be 0. This is R3, okay. R2 will be based on this. If this is R1 plus R2, what is left? That is that thing, okay. So how many terms are possible? From here, 4 terms. From here, 3. From here, 2. From here, 1. So total 10 terms are possible which are rational. Number of terms in the expansion. So x cube. Number of terms possible, okay. If we add 1, subtract 1. If we add 1, subtract 1. This is simply what? X plus 1 by x whole square minus 1 to the power n. So we can have NC0 minus 1 to the power 0 x plus 1 by x to the power 2n. NC1 minus 1 to the power 1 x plus 1 by x to the power 2n minus 2. Okay, it will go up to NCn minus 1 to the power n x plus 1 by x to the power 0. Okay. Hmm. So from here we are going to get the terms of, if it is if we do it, it is somewhere 1 by x to the power 2n, and here we are going to get x square plus 1. So from to the power 2n, so we are going to get x to the power 0, x to the power 1, x to the power 2, x to the power 4n, and we have x to the power 2n. From here we are going to get 1 by x to the power 2n minus 2. There is minus, yes. uh, Constant term x square dot x to the power 4n minus 4. Okay, so if you see that other term which are coming, So from first, if you see, from the first one, we are getting the power of 1 by x to the power 2n. From the second, we are getting 1 upon x to the power 2n minus 2. Like this, we are getting up to x to the power 2n. So there is one term 1. And the second one, if you see, we are getting one power as minus 1 to the power, no, it's a nc1, it will be minus n x to the power 2n minus 1 up to 1 by x to the power 2n minus 2. Similarly, moving ahead, we are going to get x 2n minus 1 c4. So maximum we are going to get this thing only. So how many terms are there? 2n plus 1 term. 2n plus 1 terms are the terms that we are going to get from here. Now this is a note is what, a1 is what. Okay, interesting question, let's do it. A1, we have to find a1. Differentiate. We are differentiating. So we'll get a1 to a1x plus something with x, isn't it? So we'll put x equal to 0. So we are somewhere going to get 10 into 2. So a1 is 20. Now this is option A. We have to find a2. This is a2. Differentiate it again. Again differentiating will make us 90. 1 plus 2x 3x square 2 plus 6x whole square plus 10 1 plus 2x plus 3x square to the power 9 into 6, which is 2a2 plus this was x square, so it will be again in the form of this was x square, it will be still again in the form of x. We'll put x equal to 0. We'll get somewhere 360 plus 60 equal to 2a2. So a2 will come out to be 210. Now it's time for C. A4. Getting A4. So what will happen? We'll divide by x cube. So this is 1 plus 2x 3x square to the power 10 divide by x cube. So we are going to get a naught by x cube, a1 by x square, a2 by x, a3, a4 x plus dot dot dot. Okay, we know a naught when x is 0, a naught is 1. A naught is 1. We know a1, we know a2. Okay, so we'll differentiate. This will become square, this will stay in x form. After differentiation, this will become a4, and we are going to get minus a2 x square. This we are going to get a1 x square. Okay, how to get it? We have to get x a to the power 4. Yes. Wait, I'm doing this. I'm doing this. Okay. x4. We have to go with multinomials. I think we'll have to go with multinomial. This trick is not working. Okay. Hmm. We have to get the x to the power 4. So a to the power 20 will be having a20 d option. So what will happen? We'll divide this 10 in R1, R2, R3. So it is what? 10 factorial divided into R1 factorial, R2 factorial, R3 factorial. And this is 2x R2, 3x square R3. So what can happen? 2R3 plus R2 will have to be 20. So what will happen? If we put R3 equal to 10, it is possible. If we put R3 equal to 9, 9 to the 18. So R2 will have to be 2, but we are left with only 1. So this is not possible. R3 equal to 8. 16 will go that side. So R2 will have to get 4. So we have only 2 left. So R3 equal to 7. So 7 will go 14. R2 will be required to have 6. So we are having only 2, only 3 with us. So R3 is 6. So R2 will require to have 8, which is not possible by us. So we have only one possibility when R3 is 10. So when R3 is 10, so this is 0, this is 0, this is 3 to the power 10. So 820 is 3 to the power 10. Okay. Now we are on A4. So 10 factorial, R1 factorial, R2 factorial, R3 factorial, 2x to the power R2, 3x squared to the power R3. So R2 plus 2R3 should be equal to 4. So what can happen? When R2 is 0, R3 is 2. When R2 is 1, no possibility. When R2 is 2, then R3 is 1. When R2 is 4, R3 is 0. So we have only this much possibilities. So we can simply calculate it by doing 10 factorial, 0 to 8 factorial, 2 factorial, and this 10 factorial, 2 factorial, 1 factorial, 7 factorial, 2 to the power 2, this is 3 to the power 2, this is 3 to the power 1, so 10 factorial, 4 factorial, 0 factorial, 6 factorial, 2 to the power 4, 3 to the power 0. So this is the way we have to calculate. Okay. Now in this question, we have to find the then A naught A4 like this. Okay. A naught A2 A4. Okay. So putting x equal to iota will work. Let's see it. 1 plus iota minus 2 to the power 20. It will become A naught A iota A1 iota minus A2 minus A3 iota plus A4 plus A5 iota minus A6 iota A7 iota plus dot dot dot. And if you put x equal to minus iota, we have 1 minus iota minus 2 to the power 20. This is A naught minus A1 iota minus A2. Okay. So we have to get A naught A2. Okay. We are getting minus minus. So this we can get again plus A3 iota. But we have to get A naught A2 A up to A38. Even not A40. Okay, this is the last question of the day. Hmm. Can we put x equal to iota square 1 minus 1 plus 2 to the power 20 A naught minus A1 plus A2 minus A3 plus A4 minus A6 minus A5 plus dot dot dot. Okay, it's become simpler. Hey Bhagwan. So we put x equal to 1. It is 4 to the power 20, which is A naught, A1, A2, A3, A4 plus dot dot dot. Add both of them. 4 to the power 20, 2 to the power 20 is 2 A naught, A2, A4 A6 plus dot 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 A38 A40. We are going up to 40. So it is nothing but 2 to the power 39 plus 2 to the power 19 is equal to A naught, A2, A4, A6, A38 plus A40. A40 is only possible when this is 20. So this is 2 to the power 20. So this is 2 to the power 20. We solved it in last example if you remember. So this is nothing but 2 to the power 39, 2 to the power 19 minus 2 to the power 20 is our required answer. Okay. So we are done with complete binomial. We'll meet tomorrow with the new